Welcome to the project section. This is your first project. We have a product called Vprofile. It is a website written in Java, consists of multiple services. You will be deploying this product on 5 virtual machines. Like we have WordPress where we have Apache and MySQL service running on the same VM. Here you will be having 5 services running in 5 different virtual machines. In real time, you will be working in a product and you should have a local copy of that product where you can do your experiments. This project is created keeping this scenario in mind. Take a look.
And let's log into Web01, and this is where we are going to set up Nginx. Web01 is Ubuntu machine. All the other VMs were CentOS. Web01 is going to be Ubuntu. So as we run yum update, here we are going to run apt update and apt upgrade both. Apt upgrade -y, which will update all the packages. Alright, so upgrade completed successfully. Let's log in as the root user now. And we will install finally the Nginx service. Apt install Nginx. And we are going to create a configuration file which will be used to redirect request from Nginx to Tomcat server on port 8080. So our Nginx will basically act like a load balancer. So create the file at this location. Let me show you once again. That location with that name, Wipro app sites-available. This is where we create the configuration. And we create the file with the name Wipro app. And we are going to put this configuration. So front end, it's going to listen on port 80. If you access Nginx service on port 80, it's going to route the request to Wipro app server app 01 on port 8080. If you have multiple application server behind the scene, then you can just copy the settings multiple time and you can change the host name app 01, app 02 like that. But we just have one application server and we have given its name and the port number. Tomcat runs by default on port 8080. Okay, let's save this file. And we are going to remove a default application or default website of Nginx. The path is etc nginx sites-enabled default. And now we have to create a link, ln-s, link of our configuration file at this particular location. You can give it with the same name, Wipro app. So this is going to enable our site. Once the configuration changes is done, restart Nginx service. And that was the final command of our stack setup. Hello and welcome. This is a follow-up video from the previous project. In this video, we will see how to set up this entire stack automatically. We are going to run just vagrant up command. All the VMs will be provisioned automatically, and also all the services Nginx, Tomcat, RabbitMQ, Memcache and MySQL will be also provisioned automatically. So almost similar design as the previous project, except here we will be having bash scripts that will get executed automatically. And these bash scripts will provision all our services, the entire stack. Welcome to the project. In this project, we are going to set up a web application stack. The name of the project is Vprofile Project Setup. local. Let's understand about this project. In this project, we will be setting a multi-tier web application stack. The setup will be locally on your laptop or on your desktop. There are two reasons why we are doing this project. The first reason is this project is going to set up a baseline for our upcoming projects. We're going to do a lot of projects, like we're going to deploy our stack on AWS, we're going to refactor it, we're going to containerize our applications, we're going to deploy the projects on Kubernetes cluster, and many more things. To do all the upcoming projects, you need to understand Vprofile project first, and for that we are doing a setup on our local machine. The second reason of doing this project is so you can set up your own lab locally. If you have any project, you're working in any project, you can set up that entire stack locally and do all your R&D. Let's take a scenario from your real-time experience. Let's say you're working in a project, and in your project you have varieties of services that you deal with. You may be having services like database services, MySQL, PostgreSQL, web services, Apache, Nginx, application services, maybe like Tomcat, JBoss, Glassfish, or any other stack like that. And you may also have a runbook or a setup document to set up your project stack. Let's talk about some problems. You may not be comfortable in making changes in the real servers. You have the setup document, you have the runbook, but still we lack in confidence in making changes in the real systems. So you would like to set up a local stack. You would like to set up all that stack on your local machine, probably by using virtual machines. So you can do that, but the local setup is complex, it's time consuming, and it's not repeatable. So we would love to set up stack locally by using virtual machines, so we can do R&D and gain some confidence on our project. But since the setup of multiple services is complex, it's time consuming, and moreover we can't do it again and again, it's not repeatable if we do it manually, so we avoid this setup. So solutions to our problem: what we can do is we can have a local setup, yes, but it would be automated, it would be repeatable, because we're going to have infrastructure as a code. So if we have a code to set up the entire stack locally, we can do it as many as time, it's gonna be repeatable, it's completely automated process, so you can do as much as R&D you want on your local machine. Alright, now let's see what are the tools that we'll need to set up this stack. So starting with, we will need a hypervisor, Oracle VM VirtualBox we are going to use, on which we are going to set up virtual machine. But since this is going to be automated, so for automation we are going to use Vagrant, and we need to execute some commands, not some, many commands. So we'll be using a command line tool, git bash, which will be multi-purpose for executing commands and also for version control. We can also use an IDE, so you can use Sublime Text, or if you have any preference of using Notepad++, Visual Studio or anything else, that also you can use. You must have installed all these tools already from the prerequisites video. Let's understand the objective of this once again. We're going to learn VM automation locally. This project is going to set up a baseline for upcoming projects, and we will also learn how to set up many real-world projects on our local machine automatically, so we can do as much as R&D we want. Now we'll see the architectural design of various services in our project. We have Nginx, Tomcat, RabbitMQ, Memcached, and MySQL servers. So we'll see the architectural design. We'll also see one more architectural design of our automated setup. We will have a Vagrant, VirtualBox, Git Bash, and also some scripts and commands. Okay, long story short, we will be setting up a website, a web application, and this web app is a social networking site written by developers in Java language. Now we will understand the flow of this entire stack. The word stack is used for a collection of services working together to create an experience. In this case, a web app or a social networking app. So we need to set up all these services in our virtual machines and configure together so user get that experience of a web application. Okay, so the user opens the browser or the app. In the browser, the user will enter the URL. But in this project, we don't have a URL, we have an IP address. In the next project, we'll see how to set up a URL. But now we will open a browser, or the user will open the browser, enter the IP address. This is the IP address of a load balancer. And we are going to use Nginx service to create the load balancing experience. Nginx is a web service just like Apache HTTPD, and it's very commonly used to create the load balancing experience. So in one of our VM, we will be having Nginx service, and we'll configure it in a way as soon as the request comes, it is going to route the request to the Tomcat server or Apache Tomcat service. Apache Tomcat is a Java web application service. Once again, Java web application service. Pause the video and let that sink in. So if you have a web application written in Java, Tomcat is a very famous service to host it. So the application which is written by the developer will be sitting here. And if your application needs an external storage, you can use NFS service. If you have never heard of NFS, I recommend you do a little research. We will be talking about this again in AWS, but understand what is a shared storage for now. If you have cluster of servers and if you need a centralized storage, you can store it in NFS. Very commonly used. Okay, coming back to our application. So our application will be living here. The user will get a web page. The user will log in. The login detail will be stored in MySQL database service, and we'll come to that. Now here there is also one more service called RabbitMQ connected to Tomcat. And in our project, this is really dummy. It's not functional. The reason I included this is to create little more complexity so you can practice more. In future, we may be adding few more services like this, which may be functional, may be dummy. RabbitMQ is a message broker, or also called as queuing agent. To connect two applications together, you can stream the data from this. You don't need to dig in much about this as a DevOps engineer, but you should know there is such service. Message broker or message queue or queuing agent. Okay, coming back to our application once again. So our application, which is running in Tomcat, accessed by the users. And the user will log in with username and password. When that happens, our application will run an SQL query to access the user information stored in MySQL database. But before it goes to the MySQL database, the request will go to Memcache service. Memcache is a database caching. It will be connected with the MySQL server. MySQL server will store the user information. When the first time the request comes to the database MySQL, it will be sent from the MySQL server to the Tomcat, and then it will be cached to the Memcache server. So next time a request comes, the same request comes, it will be accessing the data which is cached in Memcache service. Just like you have browser cache, we also have database caching. Memcached is a very famous database caching service. Okay, so here's the entire stack. Pause your screen, take a look once again, rewind the video if you need to understand all these services. Also, do your own research. It is very important for a DevOps engineer to understand the flow of the stack. So whenever any issue comes, we can understand where it is originating from. Like if the user is not able to log in, the web page is coming, user is not able to log in, probably it is the database service not connected to the application. Or if the web page is not showing properly, it's the Tomcat. Now we cannot dig into each and every service and understand it in detail, because as a DevOps, we are more involved into the implementation rather than the functionality. But yes, you should know the functionality. So if you feel you need to know more about a service, you can do your own research, but we will be using these services many times in the course, in AWS, in Docker, in Kubernetes, in Jenkins, Ansible. So by the end of the course, you'll have a very good hand on all these services. Let's look at it one more architecture of how to implement it. Another design we have is for our automation stack. We will be using a Vagrant to automatically set up our virtual machine. So Vagrant is going to communicate with Oracle VM VirtualBox, which is the hypervisor, and create automatically virtual machines on that. Then we'll be using some bash scripts or bash commands to set up our services: Nginx, Apache Tomcat, Memcached, RabbitMQ, MySQL. So we will automatically create virtual machines from Vagrant, virtual machine for Nginx, Apache Tomcat, Memcache, RabbitMQ, and MySQL. Okay, finally, let's understand the flow of execution. First, we are going to set up all our tools from the prerequisite videos. If you have all this set up already, then you can clone the source code, which will be seen in the project. We're going to cd into a Vagrant directory in the source code. There will be a Vagrant file. We'll bring up our VMs automatically from that Vagrant file. We'll validate all our virtual machines if they're up and running and able to interact with each other. Then we're going to start setting up all our services one by one. First MySQL, then Memcached, then RabbitMQ, then Tomcat, and finally Nginx. And of course, we're going to build our application, our Java application, and deploy it. Then we're going to finally verify all this from our browser. Open your browser and access our source code URL. Switch to branch local setup. In this branch, you will have a directory Vagrant. We have 4 folders here. We are doing manual provisioning, so we'll be using manual provisioning. But if you have a Mac OS M1 or M2, then go manual provisioning Mac OS M1 directory. I have Windows here, so I'm going to click here on manual provisioning. And also for Mac OS with Intel chip, use this manual provisioning directory. We have a Vagrant file and a PDF. This document will show you how you can set up this entire project step by step. You can use it as a reference. And also we have a Vagrant file here, of course, which is going to launch all our virtual machines automatically. So we will clone this source code on our local machine and we'll get started. So I'm going to copy the URL, open my git bash. I'm going to get into F drive. You can select any place, any directory in your system, get into that. If you're using a Mac OS, if you're MacBook, then you can open your terminal. You should have Git already installed. And I'm going to run the command git clone and paste the URL. This is going to clone the entire source code in my local machine. Okay, now I should see Vprofile project directory. That's my repository. I cd into that. Let's clear the screen. I'm going to switch to branch local -setup. And I see the Vagrant directory there. Let's get into that. Okay, ls. And you see here the 4 folders. Based on your operating system, get into the right folder. I'm getting into manual provisioning. If you have a Mac OS M1, M2, then just say underscore and Mac OS M1, get into that. For a Windows and Mac OS with Intel chip, get into the manual provisioning directory. Let me expand it. Clear the screen. And we have the Vagrant file over here. Let's see this Vagrant file from Sublime Text Editor. Okay, open my Sublime Text Editor and I'm going to open folder where I have cloned my source code. So yes, it's in F drive. That's the repository. And we'll say select folder. Let's expand this. So we have Vagrant directory, manual provisioning, and the Vagrant file there. Let's understand this Vagrant file first. Well, Vagrant will use this file to launch 5 virtual machines. One will be Nginx, one Tomcat, one RabbitMQ, one is Memcache, and the other one is the DB machine. We have few global settings here. Config host manager enabled true. So if you install the plugin, then this setting will automatically update host name in each and every virtual machines. So in every virtual machine in etc host file, the host and IP addresses will be mapped. Nginx virtual machine we have given name web01, and it is going to be based on Ubuntu operating system. That's the host name web01, and it has a private IP. You can keep the same IP if it does not conflict with your existing network, or else you can change the IP. Tomcat virtual machine name is app01, and we are going to use CentOS 7 operating system here. IP address in the same network, and we are also going to give it an extra boost of RAM, 1 GB of RAM. Next is RabbitMQ, RMQ01. This will be also based on CentOS 7 operating system and an IP address. Next, Memcache, name MC01, based on again CentOS 7 and an IP address. MySQL, name is DB01, CentOS 7 operating system, and again IP address. If you see, all these IP address are in the same network, and then they would be able to communicate also with each other. If you want to make any changes like host name or IP addressing scheme, and save this file, make the changes and save the file. Okay, now let's bring up the stack. Let's open our git bash. You should be in this directory where you have the Vagrant file. You can check it once again, cat Vagrant file. Before you bring up the virtual machine, you have to install this plugin necessarily. Otherwise, you will get host manager unknown configuration error. What this settings will do is, this will automatically add host entries, map it with their IP addresses of all the VMs in every virtual machine. The second plugin is optional. If you are getting VBoxFS error, then only install the second plugin. But first plugin we need to install, so let's copy that and let's install this plugin. The plugin is installed. I'm going to run the command vagrant up, which will bring up all this virtual machine. So we already have Oracle VM VirtualBox installed. There's no virtual machine over here now, but in some time you will see all the virtual machine up over here. This is going to take some time and I'm going to pause my video. Alright, all the VMs are up. First we have Web01, that is 1 GB of RAM. Then we have App01, 1 GB of RAM again. So total 2 GB now. RabbitMQ 512 MB, that's fine. Memcache 512 MB, so now total 3 GB. And then finally DB01 also 512 MB. So you will need almost 2.5 to 3 GB of RAM to set up this stack. Okay, stack is set up, the VMs are set up. Let's make a test, let's validate. Vagrant SSH Web01 first. Okay, we are in. Let's check the etc host file. So this gets automatically updated as I told you. And let's see if we are able to ping app01. Yes. Let's log out from here. Let's log into app01. Okay, let's check etc host file in app01. That's also updated. Let's ping the backend services which this machine will try to connect. MC01, RMQ01, and of course the DB01. Okay, this is important to validate because our Nginx is going to connect to our application server, and application server Tomcat is going to connect to DB, MC, and RabbitMQ. Okay, so we need to make this test. Now let's log out from here. Okay, now you can open the setup document. And you can follow the setup document. So we have already done our prerequisites. Our VM are already set up, did Vagrant up, all the VMs are up, and we validated everything. Now it's time for provisioning. All these services we are going to provision, but we are going to provision it in this order. First MySQL, then Memcache, then RabbitMQ, then Tomcat, and then Nginx, and then finally we'll deploy our application. Okay, let's first set up a MySQL service, and there are many commands over here. So in this section we practice executing all these commands. We will be doing all the setup manually. In the next section we will see how we will automate this entire setup by using bash scripts. If you understand all the commands, well and good. If you do not understand, do not stress too much. You will slowly get hold of this. We will be seeing this product setup on AWS containers, different places, so you will get practice of it. Okay, so let me open my git bash and I will log into db01. Okay, I am in. I'm going to switch to root user sudo -i. So it's a newly provisioned operating system, and whenever and wherever you install or set up a new operating system, you should update all its packages. We will be doing it with yum update command, yum update -y. This is the command in CentOS or RPM based operating system. It will read all the old RPM packages and update to a newer version. This is going to take some time. I'm going to pause my screen and come back when it is completed. Okay, that completed. Now I will be running yum install EPL release. This will enable EPL repositories so I can install many more softwares, and it's already installed. Okay, next we will be installing Git and MariaDB service. Okay, that got installed. Now, one quick note over here, MariaDB server or MySQL server, both are same service with different package names. When it comes to RPM based CentOS, Fedora, we will be using MariaDB-server package. In Ubuntu, we still have MySQL server. So if I say MySQL server or MariaDB server, it's the same thing. Okay, next we will enable and start MariaDB service. Systemctl start MariaDB. And you see the package name is different and service name is different. Okay, sometimes package name and service name are same, sometimes they are different. So you just need to find that out. Okay, started and enabled. Next we will be running a command. Actually it's a script, MySQL _secure installation. This is going to ask you series of questions just to make sure your MySQL service is secure. So first enter root password. We do not have any root password. Now this is the root password for MySQL service, not for the Linux. This is not Linux root user. Just hit enter over here. And now you need to set root password. So I'm going to say Y, yes. And I'm setting admin123. I also recommend you use the same one. Just for now, hit enter. Again, admin123. Remove anonymous user, Y. Disallow root login remotely. So with this root user of MySQL, do you want to log in from a different computer remotely? If you want, say yes. If no, say N. I will be keeping it as yes because we may need to do some testing later. Remove test database, yes. Reload privilege, it's like refresh, yes. Great, MariaDB service is secure now. Okay, now we will log into this MariaDB service or MySQL service by using MySQL client. MySQL -u, the username root, -p, and you can specify password here itself. That is the password that I set. And no space in between -p and the password, no space. Just hit enter. You will log into MariaDB service. This is the prompt. You see the prompt has changed. Now Linux command won't work here. Only SQL command will work. So this is one SQL command that you are running. First one, create database accounts. Make sure every SQL command ends with a semicolon. So database name accounts is created. This is specifically for our Vprofile project. Our Vprofile project will be storing information in this database. Okay, next command, grant all privileges on accounts database to the user admin. So this will also create a user admin, like we have the root user to log into MySQL. We are creating here admin user. Percent means @ means you can log in from anywhere, from locally or from remotely also. Identified by admin123. That is the password of admin user. And we see we have the same password for the root user. Okay, you copy paste this or make sure your syntax is proper. No mistakes over here. Hit enter. Okay, if you get this error, better check your syntax. Now syntax is all correct. This is all copy paste problem. I'm going to run the same command, but this time I'm going to remove this single quote and add it once again. Yeah, that's right. I'm not doing anything. I'm not making any change. This is copy paste mistake. Special characters, not exactly mistake. So just remove all the single quote, add them again and hit enter. It should work. Yeah, I know, surprise, right? Both the commands are exactly same. One worked, the other did not. That is because while doing copy paste, sometimes special character changes. Okay, that is all. I'm going to give this command, flush privileges, hit enter. So it's like refresh. And then I'm going to exit out of it, exit, semicolon, and out. So we are out of SQL prompt. We are back on our shell. Okay, next command, we have created the database, but we need to feed that with some data. So we are going to download or clone the source code, download data from this link. Go into that directory, run this command which will feed all the SQL query into accounts database, and then we will check whether it worked or not. So let's do it. Let's clone the source code. So this git clone command is basically going to download all this data. If you do ls, you should find a directory here, Vprofile project. Just do cd, we're in, and in this we have src directory. In that we have main. In this we have resources, and here you should have this file, dbbackup.sql. You can do a cat to this file. You can see there are many SQL queries. You don't need to look into that for now. All you need to do is run all this SQL query on your accounts database. How? Like this: mysql -u root -p password admin123 input redirection src main resources dbbackup.sql. When you're running this command, make sure you're in Vprofile project directory and you have the proper path. Run this command. Oops, my mistake. We have to select the database. Give the database named accounts. Yeah. Okay, now let's log into the database. We will just give this much. Directly log into accounts database. I am in. Or wait, let me exit. Clear the screen. Once again, let me log in. And I'm going to say show tables. And you should see all this. If for some reason you are not seeing this, then do the setup again and check your previous command, what you executed. You can run the history command and you can see all the commands that you have executed. Sometimes we make mistake, and that is fine. Just check, fix it. Okay, now this is really not necessary, but if we run this command, systemctl restart MariaDB, if we have some mistake, it can point out. If it restarts fine, we are good. Okay, this MariaDB service is up and running. We have created the database and we are good here. Okay, next service is memcache, which is pretty simple. Just install the packages, start the service, and run this command, which will allow access on port 11211. So let's do it. Okay, so let's log out from DB and log into MC01. Switch to root user and first run yum update -y to patch this. Okay, all the patching is done. Let's clear the screen. Let's install EPL-release package. And now we will install, let me clear the screen first. And let's install memcached. And that's the only package we need to install over here. Okay, package is installed. Let's start the service. And also enable the service. Let's check its status. It's active. We have to run one more command for memcache, so it can listen on TCP port 11211 and UDP port this. So anyways, we're going to access it on TCP port. So run this command and we are good to go. We can validate if it's running on the right port, which is 11211, and we see memcache service. We can see the PID, it's open on port 11211. Okay, memcache is set up. Let's log out from here and let's go to the next service, which is RabbitMQ, RMQ01. Log into it. Okay, we are in. Let's become the root user and let's run yum update -y. All the package update completed. Now let's see the installation steps. First, we need to install some dependencies. One of them is Erlang and Socat. Installing Erlang won't be direct. We have to download this RPM with wget command. Install this RPM. This RPM will set us Erlang repository. So we can install Erlang with yum install command. Once we have Erlang and Socat installed, then we are going to download a shell script, and at the same time we execute the script. Once the script is executed, it will set us repository to install RabbitMQ server packages. Then with yum install command, we can install RabbitMQ server package. Then we start and enable the RabbitMQ service and some configurations to do after that. So let's get started with this. Let's install wget. Let's clear the screen and go to temp directory. Download this RPM. Let's install it. And now we should be able to install Erlang. And that's completed. Let's now install RabbitMQ server. Now with this command, we are going to download this script and pipe it with bash so it will also execute the script. Okay, so as this says, the repository is set up. Now let's install RabbitMQ server. And finally, it's installed. Let's start the service. Enable the service. And let's check its status. RabbitMQ service is active now. We have some configuration changes with RabbitMQ. So this command is basically gonna echo this output into this file, and we also have to create user in RabbitMQ. So that's the command, RabbitMQ add user. That's the username and that's the password. You can change if you want, but then remember whatever username and password you use, because same we are going to give in the configuration file. Next, we are going to give this user administrator privilege. In RabbitMQ, we do it like this. RabbitMQ set user tag, the username, and the tag that we are setting up. Okay, after making this configuration change, it's time to bounce the RabbitMQ service. So we'll just systemctl restart RabbitMQ server. If everything is good, if our configuration changes are good, our RabbitMQ service should be running, or else you can see some error down there. Okay, till here the backend is set up. DB, Memcache and RabbitMQ. Now we'll log into our main hero, app01, where we're going to set up a Tomcat service. So in app01, switch to root user. Can run yum update -y. Update completed. Now let's set up EPL release repository. Okay, that is done. Now dependency for Tomcat, which is JDK version 1.8. That's the dependency for our Vprofile application. So you also have a higher version of JDK now, but we have to go with 1.8 for our project. JDK is installed. Few more tools: Git, Maven, and wget. Let's install these. Okay, these tools are also installed. Now we'll download Tomcat. So let's go to temp directory. We will download this specific tarball of Tomcat. Okay, we should have the tarball of Tomcat, and let's extract it. Okay, let's clear the screen. We should see the Tomcat directory. Okay, let's see the next step. So we have to add a user, and which will create the Tomcat home directory for us. Tomcat is the username, and this will be the home directory. This is where we'll copy all the Tomcat binaries. So that command, and now you should have a user called Tomcat, and you should have this home directory, usr local tomcat 8, and this is where we'll copy all our data. So cp-r tomcat directory /star, so copy everything from there to usr local tomcat 8. Now just check once. You should see all these files in usr local tomcat 8 directory. Okay, next step is to give permission, ownership of Tomcat user and Tomcat group to all the content in this directory. So let's do ls-l, and you will see these are all owned by root user. So let's change that ownership. We will say chown tomcat dot tomcat usr local tomcat 8, and we'll give the option -r. So recursively everything will be owned by Tomcat user and the group. So you should see Tomcat user ownership and the group ownership. Alright, next step is to create this file, tomcat.service file, and we have this entry over there. With help of this, we can use systemctl command to stop Tomcat service. So let's open that up with vim. So it's going to be a new file. Okay, I will be using just vi, and copy all this content carefully and paste it here, being in insert mode. Let's do some line spacing. Okay, so when we say systemctl start tomcat, it is going to run this command. When we say systemctl stop tomcat, it will run this command. So we don't need to manually run this command, and we can enable this service by using systemctl, so it comes at the boot time, which is very essential. Let's save and quit. Once you make any change to tomcat.service file, you have to say systemctl daemon reload. So any other kind of services files also, if you have in this directory, it will reload all the changes. And now you should be able to do systemctl enable tomcat. So the service name is same as the file name, tomcat. Oops, that's my mistake. Okay, and then you can say systemctl start tomcat, and let's check its status now. And you should see it active running. If you see some problems over here like failed, make sure you check the content in usr local tomcat 8. Check the ownership of this directory, and also inside the content should have Tomcat ownership, and also verify the systemctl file if you have the right content or there are no syntax errors. So check all this, fix things, do systemctl daemon reload, and it should be working. So Tomcat service is up and running. Now we are going to build artifact from our source code and deploy to Tomcat server. So let me clear the screen. Okay, let's see. We set up memcache, RabbitMQ is done, Tomcat setup is done, and now code build and deploy. So we're going to clone the source code, we're going to build the source code by Maven, and then we're going to deploy our artifact to Tomcat web apps directory. So let's do this. Okay, I'm in the temp directory still, and I'm going to clone the source code over here. Git clone. Okay, source code is cloned. Let's get into the source code directory. Git status. So you should be in this branch, local setup branch. Now before we build our artifact, we are going to update the configuration file that will be used by our application to connect backend services, the database, memcache, and RabbitMQ service. And that file location is in the repository src main resources application.properties file. Open this file and make the required changes for a database, memcache, RabbitMQ. So let's make changes to MySQL. So we have created our VM and we have the hostname db01, and that's the same entry in etc host file, so we don't need to change this. We have created a user admin, so we'll keep the same user over here with password admin123. If you created the admin user with a different password, change those. Backend service mc01, we have the memcache service with the same name and running on the same port. We already validated that. RabbitMQ rmq01 port 5672, it runs on that port by default, and we created a user in RabbitMQ with test and the password as test. So we really don't need to make any change, but this is a very important file. Understand this file very well, because in further the other projects we have to keep making changes to these files. So if you're good with all the changes, save and quit this file and run the command mvn install from the repository, which is going to build our artifact. Okay, after some time the command completed successfully and it says we have artifact at this location, ls. So we have a target directory. Let me clear the screen. Let's get into the target directory, and in this directory you have vprofile -v2.var. That's our artifact, and this we are going to deploy in Tomcat server. And we have built the artifact in a Tomcat server itself, so it's just gonna be a copy command. But first I'm going to remove the default application of Tomcat, and for that purpose first I'm going to shut down Tomcat service, systemctl stop Tomcat. Let's check its status if it's down. And now we will remove the default application, usr local tomcat 8. You have web apps directory in this, and this you should have a root. If you have root and root.var both, you can just say root star, but there'll be just root directory for now, so just remove that directory. That's the default application, it's gone. And we'll replace our artifact, our default application that we just deleted by our artifact. So we'll copy our artifact vprofile v2.var to usr local tomcat 8 web apps with the name root.var. Make sure while you're copying you give that name. Let's copy that. Let's check whether it's copied or not. Okay, now we'll start the Tomcat service. So systemctl start Tomcat. Once we run this command, it should extract the root.var into a root directory. And now that our application becomes the default application for Tomcat. After that, wait for a few minutes. Our application takes little time to come up. Now, by the time our Tomcat application is coming up, we'll set up Nginx service or final service. So let's exit from here. So now finally, let's go through the flow of execution, what all we did. We had all the tools that we need. We cloned the source code. We get into C Vagrant directory. We brought up all our VMs. We validated it. And then we have set up all the services one by one. First MySQL, then Memcache, then RabbitMQ, Tomcat, Nginx, and finally we have also deployed our application. And now it's time to verify our website from the browser. So we're going to access Nginx service. So I'm in web01. Let's get its IP address. 192.168.33.11. So let's copy that. Let's open a browser. So just paste the IP address. We're accessing it on port 80. You don't even need to mention that. That's the default port. http:// and the IP address. And you should see this login page. This is coming from Tomcat. So Nginx is successfully routing the request to our application server. And now let's log in. So we have the username admin_vp. You have to log in with this user. And the password is also same, admin_vp. Let's click on login. If the login is successful, that means database db01 MySQL server is connected. Okay, because this user detail is coming from the database. Okay. We'll also verify other backend services like RabbitMQ. So for admin_vp user, you have few buttons over here. You can click on RabbitMQ. It should generate some queue. Let's go back. Let's check also Memcache. So click on all users. It's going to load all the users from the database and store it in Memcache. So let's select a user. Let's select the same user. Or let's go for some other user. So it says DB data is from DB and data is inserted in cache. Okay, let's go back, and if we click same user, you'll see data is coming from cache, and you will see that loading up very quickly. So we really validated all our services in our stack. So that's awesome. The entire stack is up and running. We can even access it. We checked all this backend services. Everything is working good. Now, we have done this setup. VM we have created automatically, but provisioning we did manually. Now we will see how we can also provision automatically with some bash scripts. So for every service that we are setting up, Tomcat, MySQL, Memcache, RabbitMQ, all the services, we will provision automatically. We'll run, or Vagrant will run shell scripts for us. So let's go to our VM. Yeah, I'm logged into web01. I'm going to exit from here. And now we'll delete this entire stack. Vagrant destroy, which will delete all the VMs. If you want, you can just Vagrant halt, shut it down. And then with Vagrant up, you can bring up anytime you want. But now I'm going to set up the entire stack automatically. So I'm going to delete all these VMs. DB, Memcache, RabbitMQ, and finally, not finally, we have application server. We also have web01. So it's going to give you some pop-ups, okay, on your screen. Just say yes to that pop-up. So just update the host file. Check in your virtual box. All your VMs will be gone. Okay, let's wrap up. So By using Vagrant, we created virtual machines automatically on Oracle VM VirtualBox. Then we logged into each and every machine, executed shell commands, and we have set up services. First, MySQL, then RabbitMQ, then Memcached, then Tomcat, and then finally Nginx. Once the stack is ready, we verified as a user from the browser. We accessed the Nginx service. Nginx service then forwarded the request to Tomcat server, which then forwarded the request to message broker RabbitMQ, and then to Memcached and MySQL server. So the query that got executed on Tomcat server was then cached to the Memcache server. So this entire setup of services was manual. In the next video, we will see how to automate the entire setup. Thank you for watching this video. I will see you in the next one. So the same source code URL, branch local setup, and we have a Vagrant directory. In this we have automated provisioning directory. In this directory we have a Vagrant file, which we'll see in a moment in detail. Application properties file that will be used by our application to connect backend services, and some bunch of shell scripts. If you have not yet cloned the source code, I recommend you clone the source code. Git clone and the URL. So since I already have it cloned and it's in my F drive, I'm going to get into the directory. Let me expand it. So again, Vagrant directory. Inside that we have automated provisioning, and there we have our Vagrant file, application properties file, and bunch of shell scripts. This will look much better from Sublime Text Editor. So let's open Sublime Text Editor. Let's access our source code from here. So first we will be seeing our Vagrant file. So it's almost similar Vagrant file from as we had in the previous project. The difference in this Vagrant file is we have shell scripts executing for every VM, and the order is also different. First we are setting up a DB machine, DB01, and this will execute a shell script, mysql.sh, which we already have here. So this script will get executed. This script is going to set up MySQL service, initialize the database, take care of the firewall rule as well. And then next we will be setting up Memcache service. So Memcache, again, it's CentOS 7. It's going to execute this script, memcache.sh. This is also a very simple script. It's going to install Memcached service and make sure it's up and running. Next we have a RabbitMQ service. So it's going to bring up RMQ01, CentOS 7, and execute a RabbitMQ.sh shell script on that. Let's see the script. Again, same commands as we executed in the previous project, with little tweaks, of course, so it can run automatically. Next service is app01. Again, CentOS 7, and we'll execute the script tomcat.sh. So this script may look a little longer because it's going to also, it's not only just going to install Tomcat, but also going to set up our application, build and deploy. So first it installs the dependencies, JDK, Tomcat, and it's going to set up Tomcat service with systemctl. It's going to create the service file. And once the Tomcat service is up and running, it's cloning the source code and building the source code. removing the default application of Tomcat, copying our artifact, start the Tomcat service, wait for a few seconds, and we'll copy application.properties file. So as every Vagrant VM will have a sync directory /Vagrant, so whatever data you see in where the Vagrant file is located will be synced automatically with /Vagrant directory. So our application.property file will be existing there. So we have to make sure before this VM comes up, we edit the application.properties file with right details. So before we provision the stack, we have to make sure we update application.properties file. So backend database information is given: db01 username and password, memcache and memcache port number, RabbitMQ hostname, its port number, username and password. So all the information in this application properties file is based on the script that we are executing. Like in MySQL, we are setting up the user admin and password admin123 right there. So our application properties file also have the user admin and admin123 is the password. So if you make any change to these shell scripts, make sure you make the changes to the application properties file as well, because our Tomcat shell script is going to copy application properties file to Tomcat root directory and then finally restart Tomcat service. Okay, last VM from a Vagrant is going to be Nginx Web01 Ubuntu operating system. Script it will execute is nginx.sh. Let's see the script. So that's pretty simple. Apt update, install Nginx and create Vpro app file with these settings. So this is the backend server name app01 and port 8080. And then we move this Vpro app file to this directory, remove the default application, create a link, and finally start and enable Nginx service. So everything is interrelated together through this Vagrant file. So let's get into action now. And we are going to take very little action. Maximum action will be taken by Vagrant. So open your git bash, get into the source code, Vagrant directory, automated provisioning, and the action is only this much. We are going to say Vagrant up, and it will start bringing up all the machines. Let's check VirtualBox. So first it's bringing up the DB machine. I'm going to pause my screen and resume when the provisioning scripts start getting executed. So DB01 VM is up and running, but our Vagrant is waiting for it to become stable. Once it becomes stable, it will start running the shell script. Okay, there we go. The provisioning scripts start getting executed. So it's running mysql.sh, this shell script. And this process is going to take a very long time. DB provisioning is completed successfully. Memcache provisioning has started now. Memcache provisioning is completed and now RabbitMQ setup has started. So you see we are not logging really into the VMs and setting up the services. Vagrant is doing that for us. This entire setup will take somewhere from 15 minutes to half an hour based on your internet speed. I'm just fast forwarding the video so you don't waste time in watching all this output. RabbitMQ provisioning started and it will also take a very long time because it's going to run yum update, install Erlang socat, which has lots of dependencies. So here also provisioning time is really based on your internet speed. I will fast forward the video till app01. App01 provisioning started. Okay, now the build process has started in app01. App01 provisioning completed successfully. Web01 has started. And Web01 also completed successfully. And now it's time to validate our stack. So we will access Web01 from our browser. We can use the IP address in Vagrant file. From Vagrant file, you can even log in, or from Vagrant file, you can get the IP address. That's a static IP, or we can even use the host name. So let's open the browser and we'll just say http://web01. That should forward request to Tomcat. There it is. Let's log in. admin_vp, same password, and we are in. So DB is validated. Let's click on RabbitMQ. RabbitMQ validated. And memcache. Let's select a user. Data is inserted in cache. And cache is also validated. So in this video, you have seen how we have provisioned the entire stack with just one command. We just did Vagrant up, and all the heavy lifting is done by Vagrant. Now, if you wish, you can keep the stack and bring down all the VMs, Vagrant halt. Stack is down. All the VMs are powered off. You can check Vagrant status also. So we have the stack, but it's powered off. If you want, you can bring it up anytime you want. You can just say Vagrant up from the same directory. So since Vagrant will do provisioning only once when the VMs are created, if the VMs already exist and you say Vagrant up, it will just bring up all these VMs. So from problems of provisioning manually, which was time consuming and not repeatable, from there we have a local setup now, which is completely automated, repeatable, and it's infrastructure as a code. Thank you very much for watching the video and completing the project. Good job there. I'll be seeing you in the next project. Till then, keep practicing. Hello and welcome to the computer networking session. This is going to be the fundamentals of networking. Very basic things we're going to cover in this. And it's very important to cover this topic before I start cloud computing or Docker or Kubernetes. So being a DevOps, you will be also in charge of managing cloud computing environments, connecting multiple systems together. And these things I'm saying because you will be in charge in automating these things. And as our golden rule, you should know how to do things manually so you can automate them. So let's see what we're going to cover in this networking session. So we'll talk about the networking components first. What are components responsible for networking? We'll be talking about OSI model and understand all the layers of OSI model. We'll talk about then classification of network based on the geography. We'll talk about networking devices. We'll understand our home network. Then we'll talk about IP addresses. What are IP addresses and how to understand different IP addresses range. Protocols. We'll understand how DNS or DHCP and DSCP service work, and we'll be also seeing some networking commands. So this session is 90% theory, and we have some commands at the end of the session which will be very helpful for you when you're doing some troubleshooting in the networking, when you're connecting multiple systems together. So what is a computer network? In today's time, you see billions and billions of devices connected together on the internet. It's not just about now the computer. You have smartphone and internet enabled devices or network enabled devices. So what really is a computer network? Well, as I see, it's a communication between two or more network interfaces. Yes, every device you're using on the network will have an IP address assigned to its network interface. Like your laptop has Ethernet adapter or wireless adapter. Your smartphone has a wireless adapter or a network interface, we can call it. Network enabled devices, as used in IoT, will have network interfaces. Because of these network interfaces which are on our devices, we are able to create a communication, or should I say communication network, where these devices can exchange data. So in short, computer network is communication between two or more network interfaces. Let's see the components that are used to create a computer network. You need two or more computer or devices, your smartphone or any IoT device. You need cable or cables to link these computer or devices or the wireless network. So this cable or the wireless network will be connected to the network interface or NIC card on each device. And of course the device itself that knows what to do with the data that it is receiving over the network. Switches to connect multiple network interfaces together, routers to connect multiple network together, or software, or simply to begin with operating system running on the device that can analyze the data that it received on the network and present it to the user. So these are the components generally used to create a network or computer network. But how do they really communicate? We see millions and billions of devices and softwares and apps. How is that you go to the market, you get a smartphone, you use an app, take your picture, upload it. There's some random phone, you have used some random app and you are accessing some random website. Everyone understands every operating system, every network interface, network devices and websites and apps understand how to communicate the same way as all the other devices does. So how is that possible? What I'm saying is, think about, we have so many languages on our planet Earth. And if every country speaks only their language, they will not be able to communicate with each other, exchange ideas, share resources. There should be a common platform where everyone can communicate with each other. Likewise, in the network or computers or devices, follow some set of standards. So the hardware vendor or the app developer or the website developer knows what standards to be followed so it can be communicated across the world. OSI model has given that standard because you have billions of people around the world using computer network and wants to communicate with each other. So for the worldwide data communication, there should be some standards, some systems which are compatible across all the devices, apps, operating systems. There should be standard of communication methods and devices also. You take a Wi-Fi router from Cisco or Juniper or D-Link or anywhere. They provide you similar kind of communication. That's because of the standards that they're following. So ISO, International Organization of Standardization, has developed this standard and which everyone has to follow. So the communication model that they developed, or think of this like a language that everybody on the earth speaks. I'm saying earth as if I'm an alien, but I want to present this important point to you. A common language that can be spoken by everyone. Like that, ISO has developed OSI, Open System Interconnection. So ISO has developed OSI. Okay, sounds similar, right? So OSI is the model of communication the standard developed by ISO. And together it's called as simply ISO OSI model, which is a 7-layer architecture. It was developed in 1984. So you have these 7 layers. If you're from a computer field, you'd have already seen this in your school or college. I remember we used to by heart this. So you have total 7 layer in this. First layer is physical, then you have data link layer, second layer, third layer is network layer, fourth layer is transport layer, fifth layer is session, sixth layer is presentation, seventh layer is application. So to tell you in short, at application layer, you have, think of your browsers or your apps. Okay, at that level. Physical level layer, like cables, the data traveling through the cable, the analog signals. And there's so many things that happens in the middle. Let's talk about it. So the basic elements of the layered model, of all the 7 layered model, is 1, services, 2nd, protocols, and 3rd, interfaces. Service is the set of action that one layer provides to the other layer. Like layer 1 is providing something to layer 2. That's a service that it is offering. That's service. Protocol is the rule. So the offering of the service or the data which is traveling from different devices to your apps to your operating system follows some set of rules that is called as protocol. So standard protocols are defined in this OSI layer, which we're going to talk about. An interface means a communication between layers. So one layer can offer service to the other layer. We'll see how that works. Let's talk about like this, sending and receiving letters instead of sending and receiving some data on the net or internet or computer network. So you have a sender and you have a receiver, okay? And sending a letter, really, who sends letter nowadays, except banks and government offices. But yeah, let's take that example. So you have a sender who wants to send a letter, and there is a receiver who will be receiving the letter. So first the letter is written and you put into an envelope and drop it into the mailbox. This is at the higher level. This is happening where sender understands what he or she is doing, okay? Knows how to write the letter, knows how to pack it into envelope, and knows how to drop it into the mailbox. Now after this, the middle layer, the letter is carried from the mailbox to the post office. The sender does not understand this concept. Maybe understand, but there is no part in it. That's the middle layer. So the lowest layer is the letter is delivered to the receiver, okay, by post office. All those things that happens in the post office, it's at the very lower layer. Really, we don't even think about how that happens. And then towards the receiver, the letter is delivered to the receiver's post office. From there, the letter is carried and put into the mailbox, and the receiver is going to pick up that letter, removes the envelope and reads it. Really, the sender and receiver is worried about just, the sender is worried about writing the letter and dropping it. Receiver is just worried about, reading it. That's all. Those are at the higher layers. So there are so many services that are provided in the middle layers and lower layer. Wow, that's a tongue twister. Similar way, if you're doing communication, maybe sending an email or a photograph or a video, you're uploading some picture on, let's say, Instagram or Facebook, right? So you may be having a smartphone or a computer, you are the sender, and the server that is going to post it on your Instagram is the receiver. Or you can take an example of mail also, sending mail. So at the very higher level layer, you have your apps, your softwares, your operating system, okay, where you write the letter or you write the mail, right? And then you click on the send button, and then all this layer 6, 5, 4, 3, 2, 1, and then 1, 2, 3, 4, 5, 6 will do all its work, and the mail is received. We'll understand all these layers one by one, but I just wanted to show you a high level view for now. Okay, now let's understand all these layers one by one. First, the physical layer. It's the lowest layer in our OSI reference model, and it is responsible for the actual physical connection between the devices, like a cable between computer A to computer B. Think of like that. And here the information is in bits, ones and zeros. So when it receives the signal, it is going to convert it into bits, ones and zeros. And it is going to send this to the data link layer, the second layer. The main function of the data link layer is to make sure transfer is error free from one node to another, over the physical layer, of course. At this layer, the data is in frame. A physical layer, the data is in bits, ones and zero. At the data link layer, the data is in frame. And here the devices are like MAC address. The physical addressing works over here. Network interface card will have a physical address, which we call it as MAC address. Then the data is presented to the network layer. Network layer works for the transmission of data from one node to other, which are located in different networks, and it works on the IP address. So when the data is presented to the network layer, it is assembled in packets, and the senders and receivers IP address are placed in the header by the network layer, the header of the packet. So bits, frames, then packets, then comes the transport layer. So it takes the service from the network layer and it really provides the service to the application layer. Here the end-to-end connection and the reliability is checked. It is responsible for the end-to-end delivery of the complete message. It also provides the acknowledgement, and if there is any failure or drop of data, it will retransmit the data. Then it's the session layer. In TCP/IP model, the application, presentation, and session layer are presented as one layer. They are responsible in the security, maintenance of the connection, encryption, decryption, and then presenting the data to your apps or to your softwares like browsers or mobile apps. So if you're sending an email, the application layer is going to produce the data which would be then transferred over the network. And if it's receiving, then it is going to assemble all the data together and present it to the application. Let's understand a few more things about this OSI model. We'll be talking about the protocols later, but what I want to show you here are the devices. So at layer 1, you have devices like hub. Layer 2, you have devices like switches, or you can call like a switch is a layer 2 device. Router or firewall or a layer 3 switch is at the third layer, the network layer. Here the IP address, like router forwards the data based on the IP addresses. Switch, layer 2 device, that is based on MAC addresses. Layer 4 you have gateways, and layer 5, 6, 7 you have devices or apps like web server, mail server, browser, your client. So what you really need to understand from all these OSI layers: one, name and purpose of every layer and the devices associated or used at that layer, and also protocol that we're going to talk later in the slides. Let's summarize all these layers. Physical layer: transmit bits over a medium to provide mechanical and electrical specification, like cables that we lay around to connect multiple devices, or even the wireless communication. Data link layer is going to organize bits into frame. Physical layer is going to give the data into bits. Data link layer is going to assemble it into frames. Network layer, we have packets. The packets travels from the source to the destination, and that's what provides the internetworking. Devices like routers. Transport layer, it provides reliable process to process message delivery and also error recovery. If something fails, it will also retransmit the data. Session layer is to establish, manage, and terminate sessions. Presentation layer to translate, encrypt, and compress data. Application layer allows your apps or your softwares to access the network resource. So understanding functionalities of all these layers and what device or apps fits at what layer is all you need to know for now. Classification of network based on the geography. Actually based on the distance between network interfaces that are communicating with each other. For example, laptop has a network interface and Google server has a network interface. Distance in between them, that defines the classification. The first obvious name is LAN, local area network. I'm sure everyone would have heard about it. Right? It's local area network where the network devices are very close to each other. Probably in a room you have few computers that are connected together through some devices or cables. That's a local area network. WAN, wide area network, like internet. Here the network interface can be far, far away from each other, as I've given you the first example. From my smartphone, I am accessing a website that is hosted in somewhere in European data centers. And I'm accessing that over the network, over the internet. Right? So internet is the biggest example of wide area network. MAN, metropolitan area network, like a metropolitan city's municipality which has computer and they're all connected in a network, or metro trains computer network system. That's metropolitan area network. Campus area network, like a office campus or a college campus where you have computers connected together in few acres of land. That kind of network is called as campus area network. Like at offices, some people call it as intranet. PAN, personal area network, your Bluetooth hotspot, your own personal network, which has a very small range. Now let's talk about the devices. The two devices we're going to talk. One is the switch. And if you're setting up a local area network, you will need a switch. Like you want to connect multiple computers together and printers and some servers together in a small room or a floor. In this case, you need a switch. Like you have a node 1, a computer 1, that wants to send some data to node 2. So data from node 1 would be sent to the switch. Switch, being an intelligent device, knows node 2 is at the second network interface of the switch. It sends the traffic over there and node 2 receives the data. And then vice versa. Switch is one of the most common device which everyone would have seen if you're even using internet, like your Wi-Fi router. There's a switch inside that. Or at bigger networks, you have big switch that has many network interfaces. You'll see a lot of cables coming out from them. And they are used to create the local area network. Routers. As a switch connects multiple computers together, router connects multiple network together. So let's say in a campus area network, you have one building where you have a switch and some computer connected to it. And then you have a second building where you have another switch and some computers connected to that switch. If you want to enable communication between these switches, or maybe computer from building 1 wants to communicate to the computer in building 2. So there's two different networks. You want to connect both the networks together, you need router. You have a router at your home that connects your local area network in your home with a wide area network, which is internet. So talking about your home network, it's very essential for you to understand your home network. If you understand that, then you can understand any other kind of network. So at your home, you may be having a Wi-Fi router or a wired router. You would be connected to your wired or Wi-Fi router through your computer, your laptop, or your smartphone. Your Wi-Fi router is not just a router, there is a switch inside that, and that's why in your home, in your local area network, all the devices can communicate with each other and can also communicate with the switch. And then there is a router, there's a routing, there's some NATing magic that happens that enables you to connect to, or that enables the internet communication. So from the internet service provider, you get a network cable connected to your modem. From modem, you will make a connection to your router. So you're connecting internet network to your router, and then you will have a switch. In this diagram, the switch is, you're seeing it out of the router. A switch or an access point will allow all the computers in the network to connect to it, and then it will have connection to the router. So traffic that is getting generated on your laptop goes to your switch, from switch to your router, from router to your modem, internet, and then it comes back. Now, everywhere the data is traveling, every device has an IP address. Your laptop has an IP address to its network interface. Switch will have an IP address. Your router, your internet service provider, and all the other computers and smartphone in your network will have an IP address. Similar to your home network, you have big corporate networks. or data center network, where you'll have many switches, you'll have many routers, and you'll have multiple internet service provider. And this is for high availability. You have many devices, multiple switches, and also for security you'll have more devices like firewalls. Right? So in the diagram you see there are many computers and phones that are connected to a switch, and they are connected to the other switch also. That switch may be connected to one centralized switch or to a router. That router will be connected to the internet service provider. Same way you'll have connection from the other internet service provider also. So here multiple switch is for high availability. If any switch breaks, the communication can be flowing from the other switch. Multiple routers because you have multiple internet service providers. Or to make the connection between multiple networks in your data center or a bigger corporate network. So same story as your home network, just many devices for high availability, and you should have some security also through firewalls and other devices. Like at your home, you have a single network, a single LAN. A bigger corporate data center will have multiple LANs, multiple subnets you can call them. You'll have a bigger network, in that you'll have smaller subnets, part of the network, subnet. Every subnet will have an IP addressing scheme, and you place some systems in that subnet, like a subnet for database server, a subnet for web server, or probably a subnet for a project, another subnet for another project. Don't get overwhelmed about all this. We are going to set up all this through AWS VPC. We're going to set up AWS VPC in AWS Part 2, and you will need all this information there. Now, talking about IP address, let's understand what is an IP address. We are going to talk about IPv4 and not IPv6, because IPv4 is really easy to understand. And based on that, you can then understand about IPv6 also. So what really is an IPv4 address? IPv4 address is a 32-bit binary number, which we mostly see it in decimal format, like this, 192.168.100.1. But it's actually a binary number, and you can see the binary values of it. I don't want to count that because that's what computers will do, right? So we have 4 octet in an IPv4 address. Octet is called because there are 8 bits, total 8 binary numbers, like 1 1 and then the 6 zeros. That's total 8. Then a dot and then next 8, then dot, then next 8, dot, and next 8. So total 32-bit binary number. So first octet, you have 192 there. Second octet, you see 168. Third octet, you see 100. Fourth octet, you see 1. Now I'm literally spelling that all for you because I'm going to explain you about different ranges in IP address, and you need to understand what is first octet, second, third, and fourth. So when I say third octet or when I say second octet, you should be looking at the right place. That's why I'm spelling it out. Okay, now IPv4 range. So entire IPv4, like all the IPv4 address, right? It's in this range. It starts from 0.0.0.0 and ends at 255.255.255.255. And that's the entire IPv4 range. Every octet will start from 0 and goes all the way till 255. Right? So let's say the fourth octet starts from 0, goes till 255. Then it ends there. Then the third octet will start. Then it will be 1.0, then 1.1, 1.2, 1.3, like that. So the entire range. And if you're wondering why it ends at 255, why does not it ends at 999, then you have to understand this is the decimal representation of binary number. It's a binary number, right? So the last number in the octet, the last binary number in the octet is 111111181. That's the last binary number in the octet. And if you translate that to a decimal, you get 255. Or vice versa, if you're saying 255, if you convert into binary, you get 8 ones. That's why it ends at 255. This entire range, which gives us billions of IPs, are divided into two parts, public IPs and private IPs. Public IP is with the internet service provider and also the cloud providers. Private IP is for people like us to create our own network. Like I want to create my own network. I will use the private IP scheme. But for the internet devices, the public IPs are used. When you get an subscribe for an internet connection, an ISP will allot a public IP to you. And that is your identification on the internet. And mostly it's dynamic IP, what we get at home. You can get a static IP also. So your identity remains same always if you get a static public IP. Public IP really means internet IP. So internet is a network, right? And in network, in the devices, you have IP addresses. So on the internet, the IP addressing scheme is called as public IPs. Private IP is, let's say you want to set up a room full of computers. You're going to take a private IP range and assign it to your computer devices or to your network interfaces. So you have 5 range in private IP, also in public. Private IP ranges, the 3 that we use is class A, class B, class C. You have class D and E, that's research and multicasting. So we really don't use them. Class A, B and C are the one that we use. So starting from class C, 192.168.0.0, it starts there and ends at 192.168.255.255. So I'll write some IP addresses or examples of IP addresses that is from class C. Okay, so for example, 192.168.10.12. This is a class C IP address. How can I say that? Well, the class C range is that 192.168.0.0, 192.168.255.255. Right? Any IP in this range will be a class C, private class C. So like 192.168.10.12, that comes in the range of this, right? Even my computer IP address. Let me open command prompt and let me run ipconfig. So my laptop IP 192.168.0.174. This is a class C private IP. Class B 172.16.0.0 till 172.31.255.255. Let's again take an example. 172.16.12.30. Let's say just 30. That's a class B private IP. Private class B IP. Right? Also, a few more examples. Let's take 172.20.19.68. Okay, even the third octet, if you see, third octet can start from 0 and go till 31. Oh, sorry, the second octet, my bad. Second octet, right? The second octet we are seeing 20, right? So second octet starts from 16 and goes all the way till 31. But the first octet will be 172 always in class B. And third and fourth octet can go from 0 to 255. So this perfectly fits, right? But if we say 172.32.36.87, now that does not fit in this, right? 32, the second octet, right? So that could be a public IP. Similarly, class A IP address 10.0.0.0 till 10.255.255.255. Now, by looking at the IP, you should be able to say whether it's public or private, and if it's private, then it's from which range. So, in a network where you have multiple computers connected through a switch, a LAN, you will have IP address to every computer, to the switch. It could be class A, class B, or class C, any range. Or a little bigger network here where you have multiple local area network connected through a router. In such case, computer A can send the traffic to computer D based on the IP address. Again, the IP could be from range A, B, or C. Or a large corporate network where you'll have multiple different network schemes connected together through different routers. So we talked about IP addresses. Now we're going to talk about protocols. Protocol in general, as we call it, as a set of rules. In networking and communication, a protocol is a formal specification that will define the procedure to communicate between sender and receiver or vice versa. It defines varieties of things like the format of communication, timing, sequence, how the error will be handled, and a few other things. like an HTTP protocol or FTP protocol or SSH protocol. So the client and the server that understands these protocols knows how to communicate by following that particular protocol. Talking about protocol of layer 4 transport layer, TCP and UDP protocol. All the other protocol that we see in layer 5, 6 and 7 are divided in between these two. So what's a TCP protocol and what's a UDP protocol? What are the differences between them? TCP protocol is called as a reliable protocol. Like for example, HTTP. When you are sending an email or uploading your picture by using HTTPS protocol, mostly that will happen the web communication. So you have a guarantee that your mail will receive at the end the same format, or your picture will be received or uploaded in the same way as you have taken it. So there is reliability over there. It's connection oriented. Between source and destination there is a connection. It performs three-way handshake before transferring the data, and it's all based on acknowledgement. There will be error detection if something fails, if packet gets dropped in the middle or corrupted. The error will be found out and the data will be retransmitted. So that's why it's called a reliable protocol. So any application that wants a reliable communication, like your browser using a website, or from your app you're ordering your food. So developer, while developing this application, if they need reliability, they'll use reliable protocols like HTTP, HTTPS, FTP based on the requirement. UDP on the other hand is called as unreliable protocol. Yes, this is also a requirement of unreliable protocol. These protocols are connectionless, just send the data and forget about it, whether it reaches its destination or not. It's much faster than TCP, and that's why it is used sometimes. Not sometimes, by a particular protocol. There's no acknowledgement. So, like send the data, and whether it reaches its destination or not, there is no acknowledgement about that. There's no proper sequencing of data. But sometimes speed matters more than reliability. So protocols like DNS, DSCP, TFTP, these falls under UDP. This is where you need fast data transmission. Like you entered a URL and that has to be transferred into an IP address, and it has to be done very quickly. A DSCP client asking an IP address over the network, it should be faster. So UDP protocol. So that's the difference between TCP and UDP protocol. Protocols will have port numbers, default port numbers. Like DNS has 53 in UDP and 53 in TCP. HTTP port number is 80. HTTPS port number is 443, and so on and so forth. Maybe take a screenshot of this or write it somewhere or by heart it. And many other port numbers, default ports that we're going to see throughout the course. It's important for you to understand what port number is for a particular protocol, a default port number. This will be very helpful when we are setting firewalls like security group or NACL. And we're going to do that in AWS, and also some places at the operating system level. So if you're wondering what are these numbers associated with a protocol, like a computer has an IP address, a service running inside a computer will be having a port number. For example, you're running a web service which is using protocol HTTPS. So the default port 443. That means it's serving the request on port number 443. Okay, think about a food court where you have multiple stalls. Stall number 1, you have Indian food. Stall number 2, you have Chinese. Stall number 3, you have Italian. Stall number 4, you have Thai. And I'm already started getting hungry. But my point is here, you have a food court. Think of that as an IP address, an address, right? When you're going to a food court, you're asking someone an address of the food court. You go to a food court and there are multiple stalls serving you a cuisine. Port number or stall number 1, Indian food. Stall number 2 or port number 2, serving Chinese food. Like that in a computer, you will have port numbers. Port number 22, serving SSH service. Port number 80, serving HTTP service. Port number 443, serving HTTPS. 25, SMTP. So in one computer, which has an IP address, can be serving multiple services also. So that's the relation, the IP address and port number thing. And that's OSI 7-layer model compared with the TCP/IP protocol model. Okay, right hand side you have TCP/IP protocol model, right? So application layer in TCP/IP, which is equivalent to 5, 6, and 7 OSI layer. So you have protocol at this layer: Telnet, FTP, DSCP, TFTP, HTTP, SMTP, and so many other. At transport layer, you have TCP and UDP. At the network layer, internet, in TCP/IP we call that layer as internet layer. ICMP, ARP, RARP, IP, the IP address, and layer 2 and 1, that is compared to the network interface layer of TCP/IP protocol model. So left hand side you have OSI model, right hand side you have TCP/IP model. So I think now you must be starting to make some sense what are we are talking about: different layers, different protocols, port numbers, and of course the IP address. So when a computer which is running, let's say, Tomcat service, which is an application, a web application service, wants to communicate with a MySQL server to store some data. So Tomcat server is going to send traffic to the destination IP address of MySQL server and the port number of the service, 3306. That's the default port for MySQL. That's how the Tomcat will have an assurity that it is going to reach to the MySQL server IP with the port number. That's how IP address and port numbers work together. When you have two computers or two virtual machines, you want to connect each other, you should know how they're communicating, what IP address they're using, and what port number they're communicating on. And of course, what protocol they're using. In this course, we are going to see a project called as Vprofile. It's a Java-based project, and there are multiple services in this project. You have Nginx, Tomcat, RabbitMQ, Memcache, and MySQL. All these services we are going to host in different virtual machines, locally and also on the cloud. So every virtual machine will have an IP address running a particular service, like Nginx. That will be running on port 80, for example, like Tomcat on port 8080, RabbitMQ 5672, Memcache 11211, MySQL 3306. And they all will be, they all will be communicating with each other. So when you work in a project, you should know what service is running in which server, what is the IP address, and it's running on what port number. Because when you connect all of them together, there will be firewalls and other things that you need to make changes to. Welcome. In this session, we will be seeing some networking commands in Linux and also in Windows. And for that very purpose, I have created two virtual machines by using Vagrant file. It's the same Vagrant file that we used in multi-VM section of our Vagrant. So one VM is Web01. It has a static IP 40.11 and DB01 40.12. Web01 is running a web service Apache 2 on Ubuntu. DB01 is running a database service MariaDB. And talking about port number, Apache 2 service is running on port 80, MariaDB service is running on port 3306, and we will find that out. So first let me log into Web01. Consider this just a testing ground. You can run these commands from any Linux machine or even some commands on Windows machine. So I am in Web01. We're going to run some command which will need root privileges. So I will already switch to root user. First command I'm running is ifconfig. This command will show you all the network interfaces or the active network interfaces, their names, and their IP addresses. So this is connected to the NAT network. This is the static IP that we have given, and this is the loopback address. Loopback address LO. This IP address 127.0.0.1. This is used when the computer is referring to itself. You can say this is the local network interface. And this will be the address of the computer on this network 192.168.40 network. This will be the IP address. So this computer is connected to two network. One is this one, the another one is this one, 10.0.2, 192.168.40. If ifconfig command does not work in your operating system, you can try IP address show. So ifconfig command is not available in newer Linux systems. So IP address show. So this is just to check your own IP address. Now if you have any other IP address and you want to see whether it's connected, like I'm going to give IP address of db01 40.12, that's the IP address of db01. So I use ping command. Ping command sends 4 network packets, ICMP packets. In Windows machine, in Linux machine, it keeps on sending unlimited packets, and I have to do Control C. So it is sending the ICMP packets to this IP address. And when this IP address receives, when this network interface which has this IP address receives the packet, it's going to reply back. And you can see 12 packets were transmitted, 12 received, 0% packet loss. So there is a network connectivity from your machine to this IP address. So that's what ping really reveals. Now if I want to connect to that machine with the name and not with IP address, I will need a DNS server, or I can make an entry in etc host file. Host file you will find in almost every operating system. And you can give the IP address of your target machine, 168.40.12, and the name db01. Then you can refer to that machine with the name, like you can say ping db01, and you will see it resolves to that IP address. So ping command really shows whether there is a connectivity or not. It can show if there is any packet loss. But if you want to trace the complete path that your computer will take to reach the target machine, then you can use traceroute. Now traceroute will not be working properly in a virtual machine, in VirtualBox. So I'm going to log out from here. In the Windows machine, either you can use command prompt or PowerShell, or you can use git bash, and you can run traceroute command. So that's the command, trace rt, and you can give a destination, like I will give www.google.in and hit enter. So this command is going to send 3 packets to the destination, which is google.com. That's currently the IP address, and it is going to show me all the hops that it is going to take to reach the Google server. Hops could be the routers. So it reached at this place, then it took the next hop over here, then the next hop, then the next hop. So it is sending 3 packets. This is the first, this is second, this is the third. It shows the latency also, 256 milliseconds for the first packet, but the second and third says 1 millisecond, so we can consider this as 1 millisecond. Second router is at this place, that's the third one. So totally 8 hops. It also shows the IP address or the name of the router that it went through to reach the Google server. This command is mostly used when you want to see there is any latency in between you, your computer, or a computer to some target machine. You can find out if you are seeing you're seeing all the 3 packets having too much latency, then you can find out, okay, the problem is over here. And it's not at your local network or not at the server. The problem could be somewhere in the middle on the internet. Okay, let's log in back to Web01. Next command we are seeing is netstat-antp. With this option, this command is going to show all the TCP open ports in the current machine. Okay, so we have port number 22, port number 80. Now it's not showing process ID. I have to be the root user. I'll run the command once again, -antp. Okay, so it shows port 22 is open, port 80 is open for anyone to access, and this is the process ID, service name, or the process name, right? This is the process. So there is an Apache 2 service running on port 80. That's the process ID. There is an SSHD service running, and that's the process ID. And you can run ps-ef command and grep for this process IDs, and you should find it. ps-ef grep, let's say 11, or I'll do it for Apache 333, or I'll just say Apache 2 process. Right, so I find the process ID 3306, and from that I can find out what port number, if it's using any port number. And I'll say grep for 3336. So I can say this process has opened this port 80. The new command is also ss-tunlp. There again 2222. You see the process ID also, port 80. See the process ID also, process name. This is to see the open ports on your machine. There is also one more command called nmap. Nmap will not be installed, so you have to install nmap. I'll say apt install nmap. And if any command it is saying it's not present, you can just find it on the internet, the right package, and install that. That command will be available then. Now nmap command, use it carefully, because in some countries it's even illegal to use this command, and it also depends from where you are running, what is your purpose. So don't run nmap on any website, any public website, right? If you know what you're doing, okay, use it for troubleshooting purpose only. If I just hit nmap, it's going to show you a lot of options. You can say nmap localhost. It shows the open ports. So 22 and 80 are open ports. You can do nmap on a target machine, like I'm going to do it on DB01. And that's actually the main purpose of nmap, scanning the port of a target. So on DB01, you have port 22 open, port 111 for RPC bind, and 3306 for MySQL. This is when you're trying to connect two machines together, they are not able to connect because of some issues from some firewall. You can use nmap to scan the port whether they are open or not. Okay, next command is dig. Dig is going to show me DNS lookup. So if I say www.google.com, so its IP address is this. There is an A record. So it's showing me the record in the DNS server. This is the DNS server. This is used to see whether your DNS resolution from your computer is working or not. That means a name can be resolved to an IP address or any other records. There's another command also, nslookup, which will be also similar to this, and you can say this is an older version of dig. Right, again name, IP address, name, IP address, that's IPv6 by the way, and that's IPv4, and this is the DNS server that is resolving, and that's the port number. Okay, dig and nslookup for DNS queries. Route-n, this command is going to show you the gateways. So for this network interface, the gateway is this, or you can just run a route. Okay, route command, you can update the route tables also, but mostly we are using it to just see the gateways. Okay, next command is ARP. This command is to view or add the content to the kernel's ARP table. So kernel will maintain a table of an IP or a name and mapping MAC address. Right, so it is saying for DB01, the MAC address is this. Okay, next command is mtr. So this is same like trace route, but this is really live. Continuously it's showing. If you want to see where is the packet loss and if it's frequent, you can just run it. But as you see from the VM, there is a problem with this. Okay, let's log out. See if you have mtr command in Windows. You don't have. Okay, I'm going to log in again. Okay, let's clear the screen. So mtr will say www.google.com. Right, so it is showing all the hop taken and also where you have any loss. At this place you see there's some packet loss, right? And I can see it dynamically. So if you're getting a slow internet, or if in between two systems there's a slow connectivity, you can find out, funnel down where the problem is, where the packet loss is happening. Or also, if you're not able to reach to a destination, it will go to a particular place and there it will start failing. 100% packet loss will be there. That means the problem is at that particular place. You can figure out whether it's your local area network, or it's whether it's the server, or it's somewhere in the middle. Okay, you can do Control C to that command. Now I have shown you nmap command, and you can run it on the target machine, and it will show you the open ports. But you can also use telnet command to see whether a particular port is open on the target machine or not. Like, you can say telnet, and you can give the IP address or the host name. I'm going to give the IP address now. That's the DB01 IP, and I'm going to say 3306. So trying to connect from web01 to DB01 on 3306. Okay, there it says connected, but the MariaDB server is rejecting it, right? That I'm not willing to connect to this IP address, right? But the port is open, it was connected. Or you can try 22, which is for SSH. There you go, SSH, it opened the connection. You have to use control and the square bracket, hit enter, and from that telnet shell you can quit. Okay, so these are some commands. We have seen ifconfig, IP address show, ping, netstat. We have also seen traceroute, but that is outside. We have seen it from the Windows machine because in the VM it does not work properly. So run it on your host, from your host machine. Netstat, we can find out a process ID, and then you can grep for what port it is running on. SS, nmap, if it's not available, install it. Dig and nslookup for DNS queries. Root command to see the gateway. ARP to see the kernel's ARP table. MTR, which is similar like traceroute but dynamic. And telnet. There are many more Linux networking command. If you just put it on Google, you'll find so many sites, and sometimes the other tools or the third-party tools are also very helpful. There are many more commands like TCP dump, you have Wireshark, but for a basic network troubleshooting, these things will be enough for you. We'll see throughout the course how we're going to use these tools. And that will be all in this video. I will see you in the next one. Welcome. In this session, we will talk about containers. How you can isolate your applications. Now, this is a brief introduction on containers. We have much detailed information on containers and Docker and Kubernetes in later sections. What you see right now on your screen is a Linux computer, and I am pointing here two important things. One is the operating system file system, or the file system hierarchy of an operating system. At the top level, you have a root directory. Underneath, you have many subdirectories like root, boot, bin, var, etc. I have explained about this file system in Linux session. If you are not aware about this directory structure, revisit the Linux session, you will find it there. Now, these files are configuration files, binary files, libraries, and many other things. The question is, who uses these files? Well, they are the processes of the computer. Like, you have Apache Tomcat process, Nginx process, MongoDB process. We also call them as service. But right now I'm just talking about the process. So there are many processes running in the operating system, and these processes will be part of process tree. At the top, you have init or systemd process, and its process ID is 1. And then this is forked into other more processes, and these processes that we are seeing, Tomcat, Nginx, are also part of this process tree. So this has been a structure from a very long time. That's how the operating system works. But I want to highlight some problems over here when we are running multiple main processes or services in one computer. Like I have here Tomcat, Nginx, and MongoDB. MongoDB is a database, Nginx is a web service, Tomcat is an application service. So these processes do different things, and they are using the same operating system, file system, or same directory structure. Now, if I make any change to the configuration, it will affect all the processes. Same with the binaries, same with the libraries. If I'm installing a version of a binary or of a library, that is going to affect all the processes here, because all the process consumes same thing. So what we need is basically isolation. So to isolate our processes, our services, we use different computers. So in this diagram, you see different servers or different computers. So for isolation, I set them into different computers. They have their own operating system. Now these server or computer could be a physical machine. It could be a virtual machine. But the point is, for isolation, I need to set them into different computers. So they have their own files, their own process tree, and they are not disturbed by each other. But this creates more problem, and which is the cost. More computer means you need to spend more money. And if you want to do it for isolation, there is a better solution. And that very solution is or are containers. Now this is similar Linux computer, similar file system structure, but what you see here is Apache Tomcat container. What is that? Well, it's just a directory. Yes. And it contains its own file system, which looks like the OS file system, and it may look like just another operating system, but it is a miniature operating system, or just it's a directory. And like that, Nginx is a separate container, MongoDB is a separate container, and they can be all connected together. You will have a virtualized network in the computer, which will give IP addresses to your container, which are just directory again. So this solves the isolation problem, but it also gives many other benefits or features. Like this is a miniature OS, it's just a directory, and it will be lightweight, it will be very small. It won't contain everything. For example, for Nginx container, it will only have files that is required to run Nginx process and the Nginx process tree. Here PID1 is the Nginx process. In MongoDB, PID1 is MongoDB process. Likewise for any computer, for any containers. And since they are very small, very lightweight, we can archive them. And these archive are called as image or container image. The purpose of archiving or creating a container image is we can ship it where? Anywhere. You can run it container from your desktop, and the same container you can archive and run it on a production server. And how all this happens, we will see that in detail later. But I wanted you to have some idea of containers because you'll hear this a lot in today's time. So who makes this possible, this containerization? So if we look at this architecture, we have on the left side the hardware, that is the computer. Now it could be a virtual hardware. That means it could be a virtual machine also. And virtual machine or a physical computer will have an operating system, and on top of that we will have container engine, or also called as container runtime environment. And this makes it possible to run containers or isolate your processes. The most famous container runtime environment is Docker. Now, how all this works, how Docker works, as I said, we have in detail in later sections. To be specific, in section 20, we have Docker. But in the next lecture, I will show you a brief introduction on Docker and little hands-on. So join me in the next lecture. Docker overview, and that's what we will be talking about in this lecture. This is straight from the Docker documentation, and this will overview, really revise what we said in the previous lecture. Docker is an open platform for developing, shipping, and running applications. Here the word application really means container that have your process in it. So you can develop your own container, which we will see later how to do. and we can ship it and run it wherever we want. Wherever you have Docker daemon installed, you can run a Docker container. A Docker enables you to separate your applications from your infrastructure. So this is what is that isolation we talked about. So you can deliver software quickly. Docker platform. Docker provides the ability to package and run an application in a loosely isolated environment called a container. Exactly what we talked in the last session. The isolation and security allows you to run many containers simultaneously on a given host. So you don't need to have multiple computers for isolation. On the same computer, you can run multiple containers. And containers are lightweight because, as we discussed, they are miniature OS. They just need files to run that particular process, like Nginx container needs only Nginx files. Okay, so you see the link, you can sure read it, and you should read it. I want you to see this architectural diagram, which we will be doing in the next lecture. So Docker host really means a computer. Docker daemon is the Docker service that we are going to install. So we will create a virtual machine. We'll install Docker engine on that, and we can run the containers. How do we run the containers? Well, they run from the image. And where do we get image from? A registry. So here I want to show you one more website or a registry. hub.docker.com. Click on explore and you can see ready-made images available here. These are the same container images we're talking about. And you see this Python, this Postgres, this Ubuntu, which is a miniature Ubuntu, Traffic, Redis, Node, Mongo, OpenJDK, MySQL, Golang, Nginx, and the list just goes on and on. I'm showing you the official images, but you can create your own images and store it on Docker Hub. We will be doing all that in section 20. Going back to the diagram. So here you see a Docker client. Now client can be on the same machine or it can be on a different machine. We will have it on the same machine. So we create a virtual machine, we'll install Docker engine in that, and that will have the client also. And with Docker build command, we can build our own images from the official images. We can pull the official image or unofficial images from the registry like Docker Hub. Docker run command will be to run the containers. When we say Docker run, that means run the container from the image. And we will see all this happening in the next lecture. Join me there. Welcome to Docker hands-on lecture. This one will be also a brief introduction, but this is hands-on. Open your Git bash or your terminal, create a directory. Like I have a directory in F drive container intro. You can create it anywhere. In that directory, place the Vagrant file that is in this resource section, download it and put it in that directory. This Vagrant file is based on Ubuntu 20. And we have some commands over here which will create or which will install a Docker engine. So the provisioning part is going to install Docker engine. All these commands, installation commands, are in the Docker documentation. Let me take you there. So over here we have get Docker in the documentation, and we are going to get Docker for Linux and Ubuntu. There's Ubuntu. And in this document you have the installation commands, so you can go through this commands if you want, but I have put everything in the Vagrant file. So we will just bring this VM and let it install Docker engine. So I will do Vagrant up and wait for some time. Okay, VM is up. I am going to log into it. Vagrant SSH. Let's be the root user, sudo -i. Let's clear the screen and let's check the service. Systemctl status Docker. So you see the Docker engine is running. Docker application container engine. Okay, let's run our first test. So back to documentation. After this installation steps, you have here a command docker run hello world. Remember what I said in the previous lecture? Docker run means create a container. Hello world is the image name. This is available in Docker Hub. So let's just copy paste this command, or I'll just run it. Say docker run hello hyphen world. Not hello hyphen world. Okay, so you see it says unable to find image locally. It's not available in this Docker engine, so it's pulling from somewhere. Okay, it says pull complete, and then it prints something. Now this container, or should I say this image, contains only this much. It's going to print, and that's all. Its job is done. This was just for the test. Some more commands. Docker images. This will show you available images on your system. Docker ps will show you running containers, and docker ps-a will show you all the containers. So you see there is a container ID. This is created from this image, and it executed some command /hello, and its status is exited because it's not running. It just came up, it did its work, printed everything, and then it's dead. And its name is relaxed summit. Okay, that name it has given itself. Now this session is just for understanding. If you can run this command, do it. If you don't want to do it, you can skip it also. We have in detail in section 20. Let me clear the screen and let me run one more command. Docker run. Yes, I'm creating one more container. This time I'm going to say --name. I will name a container. I'll say web01, and I will give nginx. This is the image name, which is again in Docker Hub. And I'm going to say here option -d means run it in the background, don't run it in the foreground. -p, small p, and I am going to give a host port, let's say 9080 colon and 80. That's the container port. Port 80 is the container port, and port 9080, this is the host port. So I'm randomly selecting a host port. Host is here the virtual machine. Now container will be running in an internal network. We cannot access it from outside. So to access it from outside, we have to do something called as port mapping. So we access this host IP and we give port 9080. So it routes the request to the container web01 on port 80. I know this is too much to handle for now, but as I said, I just want you to understand technology for now. Details later. So I'm going to just hit it. Okay, it's saying unable to find it locally. So it's pulling. Again, it's going to pull from Docker Hub. Okay, something happened. Let's do Docker PS. This will show us a running container. And yes, we see a container web01. It is created from nginx image. There is a container ID, and then there is this port mapping. Now I can access this container locally. For that I need to know its IP address. So I'm going to do docker inspect and the container name, or I can give container ID. And there I see the IP address. This is the IP of the container, and I can do this. I am going to do curl http:// the IP address of the container and the container port. Now we are internal. We are in the Docker engine. The container is running here, so we can access it locally by giving its IP and the container port. And this should show us the nginx default web page. And there you go. It's in HTML format. Of course, the shell cannot read HTML. It just prints everything. If we check it from the browser, we can see a proper HTML page. Okay, let's look at the IP address of this VM. IP address show, and this one, the bridge IP. Let's take this IP and let's go to the browser. Let's also check the host port, which is a 9080. So let's take the IP. Let's copy it. I give the IP in the browser :9080. And there you go. This is coming straight from the container. So from the outside, we access from the host port or the node port, and that routes to the container and gets us our data. Now a quick glimpse on how to build our own image. I will create a directory called images. I will cd into that. I will create a file called docker file d capital, and I'm going to paste some content over here. Right now you don't need to understand these commands. We will learn them in separate lecture in section 20. But I want you to see over here from, which is the base image, Ubuntu. So we build our own custom image from a base image. Now this base image usually will be an official image from Docker Hub, but it can be some other image, a custom image also. But there will be a base image. On top of that, we build our data. So let's just save this, and we will run a command called docker build -t, and I will give some name here, test img. You can give any name, that will be the name of our image, and dot means the location of the Docker file, which is the current working directory. Let's hit this command and wait for some time. Now this may take a long time. I had already built the image, so it took a very short time, but for you it will take a very long time to build this image. Let's clear the screen and we will say the command docker images, and we can see our image here. This is basically a web application that I have downloaded from twoplate.com. And if you remember, we did this exercise on VMs, how to set up a website on a VM. This is similar thing doing in a container. And let's just run it. Docker run -d -P, which will take the host port automatically. Let's give the image name. And now I'm going to hit enter. Something happened. Let's see, docker ps. Okay, and that is our container, and it has taken port 49154. Let's access it from the browser. Let's get the IP address of our VM. That's the IP address. Let's copy that, and docker ps again, port 49154. Okay, there in the browser, IP : the host port, hit enter, and there we go. That website I hosted in a container. So this whole lecture was about proving the point that I was explaining in containers lecture in Docker lecture. I am going to put all these commands and this Docker file into the resource section. You can get those commands and execute and test it and prove it yourself. Final thing, I'm going to do a little cleanup here. So docker ps, I'm going to stop all the running container. Docker stop web01 and heuristic Google. Then I'm going to remove all the containers. So command is docker rm and paste all the container names and remove all these containers. Finally, let's remove all the images. Docker rmi to remove the image, and I'm giving ID of all the images here one by one. So everything is clean now, no images, no containers, because we will need a clean setup in the next lecture. So if you're following me, then you also clean up everything and join me in the next lecture. Welcome. In this lecture, we will see a brief introduction of how to run your entire application set or your entire project on Docker containers. In lecture 198, I have given a detailed information of how to build it from scratch. In this one, it's a brief introduction. So as we already know about our project, we have Nginx, Tomcat, RabbitMQ, Memcache, MySQL. We are going to run it all in its own containers. So back to our VM directory, I'm going to open this Vagrant file and I'm going to bump up the memory to 2 GB because we will need that. Okay, so I uncommented these lines and I'm going to give here 2048 MB, which is 2 GB, and let's reload this. Vagrant reload. It's up. Let's log into it. Okay, let's be the root user. Let's clear the screen. I'm going to create a directory called as compose. I go into this directory. Now there is one more tool. We have been using Docker, but there is also one more tool, Docker Compose. Docker Compose. So it says define and run multi-container application with Docker. That's what we need right now. We have multiple containers: Nginx, Tomcat, Memcache, RabbitMQ, and MySQL. So multiple containers we have to run together, and I have already created images for this, which is on Docker Hub. If you go to Docker Hub and just search Imran Visual Path, you will see many images that I have created over here. I'm going to use these images. As I said, how to build these images from the scratch and do everything from the scratch is in lecture 198, which you can go later. So let's go back to our terminal. Let's clear the screen. You're going to run this command wget and this link, which will download a file called dockercompose.yaml. The link is in the resource section. There's the dockercompose.yaml file. Let's open it. And again, you don't need to understand the entire file here, just few things. Services means containers, and these are the names of the container. The image is specified over there and the port number. This file is in YAML format, which you will learn in Python section, what is YAML and how to write it. And also you'll have lots of hands-on practice on YAML in Ansible section. So this is going to create all our container from the images that are specified and going to run it on the specified port. So I'm just going to quit from here, and all you need to do, docker-compose up-d, which will run all our containers in background. This will take some time. Okay, seems everything is up. Let's check docker ps. Okay, that was slow because it's just 2 GB of RAM. If you feel it's still lagging, you can just bump up the memory to 2.5 GB or 3 GB if you have enough resources. But we're done here. We are going to access the Nginx container, and that is running on host port 80. So let's get the IP address of our VM. Now you see that's very slow. Okay, that's the IP address. Let's get it. Let's go back to our browser. And port 80, because that's the host port that we have configured in Docker Compose file for Nginx container. And let's just hit enter. And there we go. Let's log in. So user admin_vp, and the password is also admin_vp. Now all this is already configured into the images, so I can log in also. Okay, we are in, and we can check RabbitMQ. That's working. We can check Memcache. Let's click on a user ID 11. Okay, data is inserted in a cache, and that is the Memcache container. Let's click on it once again, and that was faster. All right, so you have seen how the entire application set can be run together, and we will see later how to build it all from the scratch. But the moral of the story here is how easily we can ship and run our containers. we have images, we can ship them, and with Docker Compose, we can run them together. Right, and this is just in a test environment. Later, we will also see how to run it in production environment by using Kubernetes. So that is all in this video. In the next video, we will understand the difference between monolithic and microservices applications. So wrap this up and join me in the next video. Welcome. In this lecture, we will talk about difference between monolithic and microservices application. And first, I don't want you to think about here VMs and servers and stuff. Think it from a user or a developer point of view. What you see right now on your screen is a Java application, just like Vprofile, and it's written in Java. And this Vprofile service has many sub-services in it, like user interface, from which user will log in and see the dashboard. Posts, so user can create or read posts. Chat, users can chat with each other. And notification, anything happens, user gets notifications. So these are the sub-services from this main service. And to host this entire application, we have used Tomcat server. Now all these sub-services are part of one big service or one big application. If you want to make any change to any of the sub-service, then you need to redeploy the entire code, entire artifact. So in Vprofile, we have vprofile-v2.var. That is the artifact that contains all these sub-services. And everything needs to be written in Java because it was started its journey from Java. So everything is in Java. This is a monolithic. The entire application, sub-services, everything is in just one single application. And it's like an elephant, difficult to move or slow while moving. Nowadays, you'll hear a term called microservices a lot. So how is a microservice application different than this? This is the architecture of a microservice application. So the sub-services we are talking about, the same thing we're going to call them as microservice. Like user interface. For user interface, there will be a separate application built, and let's say it's written in Java. And for chat, another application is built which is written in Node.js. For notification, Python. And now these all are different application or different services. They will work together, but they are different. They can be deployed on different server and they can interact with each other, but microservices applications, microservices will interact through an API gateway. So this will be interacting or communicating with APIs. So it really doesn't matter it's Java or Node or Python or any other technology used. As long as they provide APIs to interact, they can interact with each other. Of course, they should be designed to interact. Now, Vprofile was one single monolithic application, but when you have multiple applications, multiple microservices, you need to deploy them and run them. And for that, like for a monolithic application, one artifact you deployed on one Linux server running Tomcat, fine. But when you have a multiple application, multiple services, then you will need then multiple servers to run them. Remember isolation, right? So for Python, for Node, for Tomcat, for all this, different servers. So you can see the problem. Microservices solves a lot of problems for the developers. All the applications can be developed independently. They can have their own languages, their own libraries. But when you want to run them together, isolated, you need multiple servers. So you see the cost goes very high from an operations point of view. If you already understood what I'm going to say next, this is isolation problem. And for isolation, what do? Well, we can containerize it. And we can run it on a platform like Docker. So They are different services. Want to run it isolated? Well, let's build images for them and run it together on the Docker platform. So now you see why microservices and containers or Dockers are spoken in same sentences. With Docker or in container, you can run any container, but when it comes to microservices, the best way to run microservices is to containerize them and run in a Docker platform or any container runtime environment. Otherwise, if you do not use Docker or you do not use containers, you're going to end up investing a lot of money on the servers, on the infrastructure. That's why whenever there is microservice, you will see containers. If you want to take few more real-time examples, think about big, huge companies like Amazon, Amazon e-commerce, from where we can purchase many things. Now, how many sub-services, microservices are there? You log in, there's a dashboard. For that, there is a separate service, or we can say a separate container. For cart, separate container. For payment gateway, another container. So if you look microservices from a user point of view, you can understand it very easily. Sure, there are a lot of details and technicality that goes from a developer point of view. From a user point of view, we can understand like this. And from a DevOps point of view, we know if it's microservice, there will be containerization and we have to run it on a container runtime environment. From AWS perspective, what are microservices? Microservices are an architectural and organizational approach to software development. So you see, it's nowhere mentioned here about DevOps and servers and stuff. It's the architectural design, design and the approach of software development, where software is composed of small independent services, the microservices which we talked about, that communicate over well-defined APIs. Microservices architecture make applications easier to scale and faster to develop. We'll learn about scaling and stuff later. We have AWS and then we'll do Kubernetes and we'll talk about scaling. But faster to develop. They are independent. Their development can happen parallelly together. And we can use different technologies for different microservices. We can use Node, we can use Java, we can use Python, Ruby, and they're going to communicate over well-defined APIs. So there will be an API gateway. Now, all this we'll learn later. I just want you to solidify your knowledge of microservices from a DevOps perspective. You don't need to really deep dive into microservices, how to develop them. As long as you're not a developer, you don't need to deep dive that much. Yes, if you're a developer, of course, you need to understand it much in depth, much in detail, and you should also know how to develop microservices. So take a look on this URL, read about microservices. If you want to watch some videos, read some blogs, please do that and get a clear picture of what are microservices. That would be all in this video. I will see you in the next one. Welcome. In this lecture, we will see deployment of a microservice application. The name is eMart. This application was designed by using microservice architecture. In the front end, you have an API gateway created with Nginx, and this listens at 3 endpoints: root/API/web API. When the user accesses the URL of the website, it will be redirected to root, which is an app written in Angular. This will give the front end, also called as client app. And this will in turn connect to /API, which will be served by an application eMart API written in Node.js. And it also needs MongoDB database. And the MongoDB database we are going to deploy as a container, but it could be an independent service running from a server or from any other endpoint. This application also has /web API, which connects to an application books API, which is written in Java, and this also needs a database, a MySQL database. So all these apps that you see over here, Nginx, Angular, Node.js, Java, Mongo, MySQL, all these will be containers. Emart app represents an e-commerce application like Amazon, Flipkart, and then application can start like this and you can keep adding more microservices, like maybe another URL for videos, another URL for payment gateway, another URL for cart. So you see it's very scalable from a developer point of view as well. So we will see a brief introduction of how to set this up on our virtual machine. And it will be similar how we have seen for Vprofile project. Vprofile was monolithic. This is microservice. But from implementing point of view, we'll have a similar thing. We'll have Docker and we'll have Docker Compose. So let's take a look into that. I'm in a directory F micro app and I have a Vagrant file over here. You can download this Vagrant file from resource section and put it in any directory, like I have kept it in micro app directory. This Vagrant file is similar to what we have seen in previous lecture. Ubuntu 20 is the box name. Public network, so it gets in bridge IP. And a RAM size is around 3.5 GB. At the end, we have the shell commands, provisioning commands, where we're installing Docker and we're installing Docker Compose. So let's bring this up. Let's say Vagrant up. My VM is up. I will log into it. Vagrant SSH. Let's be the root user. Let's clear the screen. Now you will run a command which will clone a source code that has all the required files to build this entire application. Command is in the resource section. Git clone and the URL. Clones the URL. We will go into the repository, Emart app, and there is a Docker Compose file. Let's take a look into that. Now it's similar, services, and we have containers, client, API, web API. But this is not just running the container from the image, it's building context, and there is a directory which will have a Docker file. So it's going to build image, run container, map the ports, and run them together. Now to understand this entire Docker Compose file, it will take some time, and we will do that in later sections. If you want, take a look at this Docker Compose file. We have Nginx, we have Mongo, we have MySQL database. Now last, these three containers are running from the image. First three are building from Docker file. So all we need to do here is just say docker-compose up-d. Now this will take a very long time because we are building images. Those images are quite heavy, Node.js libraries and Java libraries, there are many. So it will take a very long time. So run this command and take a break, maybe grab a coffee. Alright, after some time, we see the containers are created. Let's run docker ps command. And we see all the containers running. We are going to access Nginx, which is the front end, and host port is 80. So let's get the IP address of this VM. IP address show. And that's the IP address. Let's copy that. Let's go to a browser. And we dial the port 80, which is not even necessary. That's the default port for HTTP. So it goes like this, http:// like that. And that is the application. Now this is the front end, and it's also getting information from the Node API. We can also register. Click on register. Let's give some email address. Let's enter some password. Next. And it's asking ID number. Let's enter some number. Let's give first name and city. I'm going to select maybe New Delhi, and I will say register. I think that got registered. Now this information is going in the MySQL database. Let's enter the password now to log in, and we are in. It says hi Imran, and we have the product list, and here we have the Booksmart that goes to the Java application Books API, and that is all. So this was a glimpse of a microservice application running on Docker platform. And that is all in this lecture. I will see you in the next one. Hello and welcome to the Bash scripting session. This is going to be one of the most exciting part in this course, especially if you are new to scripting. If you have never done or done little or no programming or scripting in your life, then you must be doubting yourself. But don't do that. Just follow along all the session and make sure you write all the scripts that I'm showing in the session. The scripts are already in the resources section, but I recommend you write it yourself. And if you're facing issues, errors in your scripts, then you can compare your script with my scripts that I am attaching it in the resources section. And one tip I would like to give you for troubleshooting scripts, from my own experience, I have seen majority of the script failures are because of the typographical mistakes. A spelling mistake here and there, a space you have missed here and there, and you get error. And sometimes it's really very difficult to look those or find out those syntax error. It could be very, very simple. So look carefully in your script whenever there is an error, compare it with my script. Just keep doing the exercises and you will find yourself by the end of this bash scripting session, you'd have gained amazing skill in scripting. So what really is scripting or bash scripting? Well, we have system admins from the beginning of the IT industry, and we used Linux servers a lot. And there are many tasks a system administrator will perform to make sure the system is always up and running and healthy and secure. Regular patching, regular backups. There are many tasks that a system admin does repetitively, again and again and again, maybe daily, maybe once in a week. So we call such tasks as robotic tasks. And instead of we doing or executing those commands in the Linux system, we put all the commands in a text file. Yes, in a text file. And we let the system execute the file for us, which is a bash script. Now the word bash is for the bash shell. If you're doing scripting for the bash shell or in the bash shell, then that is called as bash scripting. Because there are other kinds of shell as well in Linux. We have just sh, we have ksh, csh, zsh. So when we say shell scripting, it could mean any shell, but when we say bash scripting, it means specifically the bash shell script. So to automate day-to-day regular tasks, system admins write bash scripts in Linux system. Now there are many fancier automation tools in the market. You have Ansible, Puppet, Chef, SaltStack, Terraform. So why to use script or why to learn bash scripts? When you learn these tools later, you will understand that many of the concepts in those tools were derived from bash scripts or scripts for that matter. So if you have good hands on bash scripting, then you can learn those tools very easily and can even master those tools. Moreover, in this course, the bash scripting is to give you confidence and knowledge in scripting. So bash script basically tells system what to do. Instead of we executing commands, bash script or that text file will tell the system what commands to execute. That is bash script. So join me in the next lecture and see for yourself what really is a bash script. Welcome. In this session, we are going to create 3 virtual machines on which we can practice our bash scripts. The Vagrant file is placed in the resources section. You can download it from there. First, you need to create a directory somewhere in your system. In this directory, I am going to place the Vagrant file, which is in my downloads directory. So I'm copying the Vagrant file from downloads directory to my bash scripts directory where I have created in D drive. Let's get into that directory. Let's open this Vagrant file. I'm using Vim editor in Git Bash. If you want, you can use Notepad++. So there are 3 VMs in this: script box, web01 and web02. All these 3 machines are using the same box, CentOS 7, and they have their own unique IP. We are going to write all our scripts in script box, as you would have already guessed that. In first part, we will just write scripts on script box. Then we will also push scripts to web01, web02. First, we just need this one VM, so let's bring it up. I'm going to say Vagrant up script box. If you say Vagrant up, all 3 VMs will come up, but for now we just need script box. My VM is up. I'm going to log into it. Okay, first thing, we will set the host name. So we'll open the file etc hostname file, and we will give name as script box. We'll run the hostname command. And now let's log out and log in. Okay, now you see the hostname is script box. Likewise, we'll do it for the other VMs also later, which shows in the prompt so you can understand where you are currently connected to. So we will do sudo -i. We are going to write all our script with the root user. So bring up your VM, set the hostname, and join me in the next video. Welcome. We are going to write our first script, and we will place it in a directory. We'll create a directory opt/scripts. Let's get into the directory. We're going to write all our script in the command line, and we are going to use Vim editor. And as you see, Vim will not be installed by default on that CentOS box. So we're going to install Vim first. So script is really a text file that contains bash commands. So to write a text file, obviously we are using Vim editor. Let's write the script first, script.sh. .sh is in general the extension of shell script, but that is not mandatory. Let's open the file. First line in your script will be a shebang character. #! That's one character, shebang. That really gives or tells the path of the interpreter. So what basically we are telling the script when it executes is that open this interpreter and execute all the commands that I'm writing on that interpreter. If it happens to be a Python script, you will have the path of Python interpreter. If it's Ruby, you'll have Ruby path. Since we are writing bash script, so that is the path of the bash interpreter. And I'm writing a command echo, which really means print. Print what? Whatever you give in the double quote, that will be printed. So that's what I want to print, and I'm going to say echo and just hit enter. When this execute, it will just print an empty line. Also, let me write few other things. I will say the uptime of the system is, and I'll write the command uptime. Memory utilization, and I'll give the command free-m. Then I'll say disk utilization, df-h. Okay, so that's what my script is. It's going to print some statements and just run the commands. Basically, it's just going to run these commands. So let's save and quit. And in order to run a script, you have to give its path, absolute path or relative path. First, let's go with the relative path. So dot current working directory / and the script name. So I'm basically giving its relative path. When I do this, I get an error, permission denied. Well, if you check the permission of the file, it does not have execute permission for the user who is root, or for that matter group or others, does not have execute permission. So you can't execute it. So we have to give it executable permission. So I'm going to say chmod +x and the path. And then if I run it, there, that's the output, right? Yeah, it's not much readable, but let's make it more readable. Let's open the script once again. And I want to give gaps like I have. Let me set the line numbers. So at line number 5, I would like to say echo, and let's put some hashes there. After the uptime command completes, I'd like to give an empty space again and then again. So yeah, this should be printing well now. Now this makes the output readable, but we also need to make our script readable. We should be able to understand our script later when we open, let's say after a month or so, what the script is doing. Instead of reading the entire script and understanding what it is doing, we can give comments. We can use hash, and whatever we type after that will be ignored by the interpreter. So this is called as comment. So we can say this script prints system info, or I can give something like this. Let's say 3 hash and then conclude it with 3 hash. So it's like a title. And then here we can say checking system uptime. And in line number 14, I'm going to say memory utilization. Now I know the script is pretty simple, right? We really don't need to give comments, but we have to make this as a habit so our code becomes more readable. Okay, so as you see now, the script is also becoming readable and the output will be also readable. Let's execute it now one more time. Let's clear the screen. And as I said, you can give the absolute path, and you can also give, sorry, we have given the relative path. Now also you can give absolute path. So the absolute path of script is, let's clear the screen first, opt scripts for script. Okay, so you have seen we can give absolute path or relative path to execute our script. All right, one final time, let's open our script once again. And let's reiterate quickly. First line is the shebang character. Yeah, line number 1, shebang character. That is the path of the interpreter. That means open this interpreter and run all these commands on it. We have seen comments. Hash is comment in Bash, Python, Ruby, and many other places. That means just ignore everything after that except this one. Okay, this is one character. This is not hash, this is hash exclamation, shebang character. So we kind of give a title to the script, we give some commands, we give some comment, and then we give some commands, we give some spaces, and similar way. So really script is just commands in a text file which we can execute whenever we want. So that is all in this video. Next video, let's learn more feature in the scripts. So wrap this up and join me in the next video. Welcome. In this video, we will take a sample, a use case. We have some commands to execute which will set up the website for us. So instead of doing that manually, running all the commands, we are going to write a script to do that. So I'm going to call this script as website setup script, or I'll just say web setup. So I know all the commands to set up the website. I'm talking about the similar example we've seen in Linux. Download it from twoplate.com and set it up. So we know all the commands. We are going to simply record all those commands in this text file, which is basically our script. So first line, shebang character, and first just simply will record the command. So we have the command yum install wget unzip httpd -y, and if this script executes from a normal user, I would like to give a sudo -y, so it doesn't ask us any question because we have many things to do here. After this, I will create a directory in the temp. We'll call it as web files, and I'm going to use -p option. So if the directory exists, it will not throw any error, it will just simply ignore. And then we will do cd into that directory. So basically we're going to create all our temporary files in this directory. Like we have to download the artifact, so wget and the URL. So I'm at twoplate.com and let's get a template. I'm using this health center. So we need this URL. So let's go to the downloads. Let's hit F12 in our browser. It should open up this tab for debugging, and we should be in the network tab. Let's click on the download, and you should see there the link 2098_health.zip. Let's copy that link and let's just paste it here. Next, we would like to unzip that zip file, and hopefully there is a directory inside that with the same name, and we would like to copy all the content to var/www/html, and then we would like to do systemctl restart httpd. Now after installing, I would like here it to start first, systemctl start httpd and systemctl enable httpd, and we'll just keep a sudo there. And to copy here also we need to do sudo, because this directory is owned by the root user, so you need to do the sudo. And I think that is it. But also I would like to do a cleanup after this is done. I would like to remove this directory, which will contain the temporary files. Okay, this is good. This should do the trick. But now I'm going to use comments and proper print statements, so it also becomes much more readable. Alright, I have done it. Basically, I did two things. I made this script readable for me, and I have made the script readable for the user who will be executing it. So I used comments and I used proper print statements. Alright, so along with the script that you write, try to do that. So I did that for each and every step, or you can say section. Same thing, comment, and making it readable for the user. So let's execute this and test it. And I'm going to use the absolute path, but I can't do that. When the tab doesn't work, I'm not able to complete this because I have to make it executable first. So I can go into that directory, make it executable, or I can just give it this absolute path. Let's run this. Okay, we have some errors also in our script which we will fix, but really it's not that readable. I mean, it's just printing too much information for the user, which maybe user is not interested. So first let's fix the problem. The problem is this: when we unzip, we should have the directory with this name and not with .zip extension. So fix that, and that is again on line number 28. So that was one problem. We fixed that. The other thing is just generating too much information. For example, installing package, maybe I don't want to see all that information. So I'm going to redirect all the information to /dev/null. Or you know what? I'm not going to use ampersand. I'll just use just the arrow, just the redirection symbol. Because if there is an error, I want to see it on the screen. But if there is no error, then just put the output in the dev null. So that generates some output. And what else generates output? The wget, the unzip. Let's redirect this output as well. and unzip as well. And this is not giving any output. Bouncing a service, this is also fine. Cleanup also should not give me any output. Okay, we did that. How about we also print the status of the service at the end? After we've done with everything, we can say sudo systemctl status httpd, and also maybe the content of var/www/html. Let's do that once again. Okay, so the service is active, running, and we should see the content of var.www.html directory. Okay, it's time to test it. Let's get the IP address of the VM. ifconfig, I got the IP address. Let's open that in the browser. And the setup is completed. So really good work. In the next video, we will learn about variables. So wrap this up and join me in the next video. Welcome. In this video, we will be talking about variables. Variables are basically temporary storage in the memory. As we know, processes runs in the memory in the RAM, and if the process is dead, all the data along with that process, all that temporary data will be also lost. So as hard disk is a permanent storage of data, variables are temporary storage in the process which lives in the memory. So let's see how we can store variables and can retrieve them from the bash shell, or should I say bash process. So I will take a variable called as skill equal to, so skill is the name of a variable, and in that I'm storing a value called as DevOps, a text. And that's it. That's how we store the variable. To retrieve the variable, we have to use the $sign, dollar and the variable name. Now, if we are trying to print a variable, we know the command to print, which is echo. So I can say echo $skill, which will access the value of the variable. And you see there. But here the dollar is important. If I don't give the dollar, then skill is just another text. Let's take another variable called as package, if I can type, and I will give in double quotes httpd wget unzip. So this is the text basically I'm storing in the variable package, and I'll show you how I'm going to use it. I'm going to say yum install $package -y. Now that package variable will be interpolated with this value that we stored, httpd wget and unzip. And you see there, since these packages are already installed, so we get the message already installed. And yes, that's basically is a variable. Now let's implement this knowledge in our web setup script. So I'll go to scripts directory. Let me clear the screen. And let's rename these scripts in a numeric number so we can easily identify them. So first script, I'm going to say first script 1 underscore first script. Now I'm going to implement our variables concept in this script, and I would like to copy the script now with a different name, and I'm not going to make changes in this file but in the next file. So let's open that 3 vars web setup.sh. Okay, I'm going to first declare the variable on the top of the script. Alright, I have declared these variables. Package, svc, service name, httpd, URL from where it will download the artifact, artifact name, which is the directory name that will be when we extract it, and temporary directory, the place where we're going to hold temporary files. Now, if you're wondering, how did I select these things as variables? So use this logic. Things that changes or varies based on different environment or project or use cases. Like for example, If I happen to change the website from this URL to something else, then I can just update it over here. I don't need to make change in the script. Also, some things that gets repeated multiple times in the script. For example, the service name HTTPD, it is repeated multiple times, like when we are starting it, when we are enabling it, when we restart it. So if we declare that as variable, we don't need to change it at multiple places. We can just change at the variable level. So I have declared the variable. Now I'm going to use it. So instead of this package names, I'm going to just give there $package. SVC for the service, temporary files, URL and artifact name. Okay, if you see, I have used this variable smartly with .zip extension over here and here with just the name. So I can use the same variable at two different places for two different use cases. Okay, then again the service there, and finally the cleanup directory. Alright, that is done. Verify it once again after declaring and using the variable. If the names are matching, once you are good, save and quit the file. You can check it once again by doing cat. Now before I execute this, I'm going to dismantle everything, and for that I'm going to write a script to remove HTTPD, remove the service and all the data first, and then we'll execute the script. Okay, so that's a simple script. I'm going to stop HTTPD service, HTTPD. Remove the data and remove the packages. That's really not necessary, but I want you to show the execution properly. So I would like to remove everything first. Okay, there. Now let's run our 3_vars web setup, which uses variable. Great, everything seems to be fine. Let's check through the browser. And that is working good. Welcome. In this lecture, we will talk about command line arguments for our scripts. As we have been seeing arguments for commands, like for example, for ls command, we give the path of a directory. So that path is the argument. When you are copying a file, we give source and destination. We give basically arguments to the cp command or to the mv command. So we've seen many commands, and many commands needs many arguments. How can we programmatically take arguments from our script? For example, we may want to take the URL of the artifact as an argument. So user can pass any URL and our script will deploy that website for the user. So let's go to our script box. Let's clear the screen. I will write a script for _args.sh. Okay, these few statements in the scripts are to make you understand how command line arguments work. So I'm printing a message, the value of 0, and we'll say value of 0 is, and we'll say $0 there. So $ we know extracts the value of the variable. So here 0 and then 1, 2, 3, these are variables. So the $ in front of them represents that we are trying to access the value of that variable. Or here printing, we're printing the value of $1, $2, $3. But we have not stored any values to those variables. Basically, we have not declared those variables. So let's see how these things work. Make the script executable. Now, before I execute this script, I want to show you something. I take a variable x and I declare some value to it. Let's say 1, 2, 3. And I'm going to say echo $x. All right, we know that much. But what if I do not have any value to variable? Basically, let's say I have not declared any variable, but I'm trying to access it. Let's say $y, which I have not defined or declared. So it just prints empty. Since we have established this point, now let's execute our for_args.sh, which is going to print 4 variables for us, 0, 1, 2, 3. So we see the value of 0 is the name of the script or path of the script. Value of 1, well, there is nothing. Value of 2, there is nothing. Value of 3, there is nothing. It's basically those are not declared or defined when we pass the argument. So if I say first as, let's say, Linux, so that is the first argument. It will be stored into the variable 1, and you see there. Likewise, let's define the other arguments. 3 arguments in an order. And we can pass more arguments also, but we are really not using it in our script. So that's how command line arguments work. It's from 0 to 9, or should I say 1 to 9. 0 is always the name of the script. So you can say 0 is reserved for the name of the script. From 1 to 9, you can use command line arguments. Okay, let's clear the screen and let's use that in our script. So I'm going to copy our script 3 vars web setup.sh, and I'm going to say 5_args, and let's open this script and now use the command line argument. Well, it's not going to be difficult. I want to take 2 command line argument. One will be the URL, so I'm going to comment this one. Oops. Now I didn't go to the insert mode. Okay, it's not here, there, and there. So now these 2 variables does not exist, the URL and artifact name, because I have commented it, and I am not going to use the variable. I'm going to use command line argument. So here I'm going to say $1, and there I'm going to say $2. So user basically needs to pass 2 arguments, and definitely needs to pass, because if the user does not pass, this is going to be empty. So it's going to be wget empty, which will throw us error. So user definitely needs to pass the command line argument in this case. So the first will be the URL, the second will be the artifact name. Let's take the URL from here itself. First, let me dismantle everything. And how about we take a different website? And that's the benefits of variable, right? We can vary. Okay, I'm here at toplay.com, and let me select something else this time. How about this Ziggy? I like the name. Okay, so let's get the URL over here, F12. Oops. Yeah, open development tools. Network. Let's click on the download. Okay, there we get it. All right, let's run it. And first is going to be the URL, and second is going to be the artifact name, which will be this. So check out, this is now a reusable code. I can use it to deploy any website I want. And that is some intelligent work there. Let's see if it works. All right, looks fine. Let's get the IP. Let's take that and let's go to our browser. Let's try that, and there we go. Welcome to Ziggy. So that is how the command line argument works. So $1 first argument, $2 second argument. Likewise, you can go till $9. So that is all in this lecture. I will see you in the next one. In this lecture, we will talk about some system variables. We have already seen in the last lecture, $0 is the name of the script, $1 to 9 are the command line arguments, $hash means how many arguments, $@ all the arguments, $, the exit status of the last command. Now this is interesting, and we are going to use this a lot later. So let's see what this really is and how it works. So let's say I'm executing a command, free-m. Then I run echo $? So I'm checking the value of question mark. Question mark means the exit code. So I'm checking the value, which is 0. If for some reason the command that we are running gets failed, maybe we're given a wrong command, something. So I'm giving a wrong command, too many E's in the free. So that says command not found. Now if we check the value of question mark, it's 127. That's non-zero. Or let's give some different arguments. So second argument, blah blah blah, something failed. The exit code is 1. So basically what this means is if you get 0, that means the last command was a success. If you get a non-zero, the last command failed. And we also have few more variables like $user prints the username, $hostname gives the host name, $random gives us a random number. So we will be using some of these variables in our upcoming scripts. Go ahead, try for yourself. Welcome. In this video, we will talk about quotes. Very simple thing. We have two types of quotes in Bash, double quotes and single quotes. Let's see how they're different. So you must have seen so far, I've been using double quotes. So we have also single quote. So when I'm taking a variable, let's take our variable called skill and let's take double quotes and store the value. Let's try to print that. Nice. Okay, what if I do it with single quote? Now when we're doing this, we are actually reassigning the value to the variable. So this value will be overwritten from the previous value. So let's print it once again. We don't see any difference. Most of the time there is no difference, but now let's take that variable skill and let's put that variable in the double quote when we're printing. I will say I have got $skill. So the variable is in the double quote. That's the sentence and it's working fine. But now let me put this into single quote. And now let's see what happens. Now observe the output. You see there? In double quotes, the variable worked. But in single quote, when I put, it's just printing $, as it is. So this is how single quote is different. It removes the meaning of special character. $, is a special character. It has a special meaning in Bash. But if I put it into single quote, its special meaning is gone. Okay, so what if we have to print a $, and also a variable in the same sentence? Let's take a variable, virus. So I want to print this message. Due to $virus, company have lost $9 million. Now observe, this is a variable, but this is not. I want to print it as it is, but this I want to access the value of the variable. But if I do it in double quotes, this is what I get. Well, this worked, but the 9 million is just lost there, which actually is lost as per the statement. But you see, $9 actually means the 9th argument, but we don't want it as an argument. We want to print that. So we can put that into single quote, yes, but then this will happen. And this printed as it is literally, but this is not accessing the value. So what do we do in this case? Well, you put it into double quotes, but wherever you have a special character, you put a backward slash. Not forward, backward. What happens? The next character after that, if it's a special character, will be ignored. That means the next character special meaning will be gone and you will see it like this. So if you're searching for a special character in VIM editor, or if you want to print a special character, then you can also put a backward slash to remove the special meaning of the next character. Well, that's all in the quotes. I will see you in the next lecture. In this lecture, we will talk about command substitution, which you will really need if you really want to write some intelligent script. What command substitution does, it takes the output of a command and stores it into the variable. We can achieve that by using backticks or $parenthesis. If you put a command in the $parenthesis, then it's going to take the output of the command and store it into the variable. So let's see that. So let's see the command uptime. Right? It prints that. I want to store its output into a variable. Let's say I want to use the variable up. And if I put this into double quotes or single quote or without a quote, what happens is it just stores the name of the command. That's it. But if I want to take its output and store into the variable, then I'm going to use backticks, not single quote, backticks. Okay, let's take one more example. Let's say who. Okay, so who all are logged into the system, who command will return that. So let's say dollar parenthesis, and we'll see, take a variable current underscore users. Now both does the same thing. Okay, now let's use filtering and get the right value that we're looking for. Let's say I want to print a message saying that the free RAM is so and so. So I want to take this value. So I'm going to do some filtering. I'm going to grep for mem. That gives me that line. And then from that, I'm going to use awk and print dollar. Let's count it. 1, 2, 3, 4. Fourth field, and I have to put it into curly brace. Right, and now I can use backticks or dollar parenthesis and store that into a variable. I will say free underscore RAM. So now I can print a message saying free RAM is dollar free underscore RAM, the variable. I'll just say MB. So you see, if we use little logic, we can filter the right data and store it into a variable, and then we can use howsoever we want. Now let's see a simple script that will print system information or the health of the system. I have here a script which I have already created. So it basically prints welcome $user, $on, $hostname, so that user system variable, and then we are using command substitution to get the free RAM size, and we are also taking another variable load, and we are taking the load from the uptime command, again filtering with command substitution. We are storing the output, then root free variable, which takes the free root partition utilization, and then we are simply printing it over here. Now we will use this script once again later in upcoming lectures. But imagine you have a script like this print system information whenever you log into your system. And I'll show you how we are going to execute when we really log into the system. So let's run the script. Alright, there you go. Welcome root on script box. Available free RAM is 590 MB. Current load average is this much, and free root partition is this much. So we'll use this intelligence in upcoming lectures. So I'll see you in the next one. Welcome. In this lecture, we will talk about exporting variables. We have already seen variables many times, but the scope of those variables are very local. If you log out, if you close the shell, the variables will be gone. What if you want to make variables permanent for a user or for every user in the system? Then we have to export the variables. We'll see how we can do that. Okay, let's take a variable season and let's store value to it monsoon. Nothing technical, just some fun. So we know that we store the variable and then we can access it. Oops, I have to use dollar. Right, but what happens if I log out? I'm going to say exit. What exit does, it closes the current shell where the root user is logged in. Dead. So we went back to the vagrant user. Then I'm going to do sudo -i, which will switch to root user, and this time it's going to open a new shell. And in this new shell, we do not have the variable value. What happened? Well, as I said, variables are temporary in the process. If the process is dead, so bash shell was the process that's dead, so a variable is gone. So how do I make it permanent? Well, before that, let's see how we can use these variables in script that we execute from the current shell. Let's go to our scripts and let's write a script, test vars.sh # bin bash. Now what this bin bash is doing here, we know it invokes the interpreter and then executes all our command, right? I will say the $season is longer this time. Not longer, I'll say heavy. No, is more than expected this time. Now what's going to happen, it's going to open the shell and this will be a child shell for our parent shell. So this is the parent shell, and when I run the script, let's make it executable. So anyways, I logged out and logged in, so the variable does not exist, but let's do it once again, right? And it's on a current shell, right? But let's see if it is available in the child shell, and it's not, right? Here was supposed to be the variable. The variable does exist from the parent shell but not on the child shell. What you can do is you can use this command export and you can give the variable, and then it is available to all the child shell from this parent shell there. So this is what exporting does. Exporting a variable will make the variable global for all the other child shell. But this is still temporary. If I log out, log out, and then I log in back, and the variable is gone. So how do I make this permanent? What we can do is, in every user's home directory, there is a hidden file called as .bashrc. If we place our export command and variable in bashrc file, then it will become permanent for this root user. So what happens is, whenever the root user login, or whenever any user login, this file will be sourced like this. Every user will have its own bashrc file and also another file, Vprofile. So if I edit this bashrc file and place my commands or script, anything if I place over here, it will get executed. So I say export season equal to monsoon, and I'm going to save and exit. Now let's again try to print that. So it's not yet available because this file is not sourced. But if I log out, exit, and then I log in with this user, and let's try this again, it's available because the bashrc file was sourced when the user logged in. So every user will have its own bashrc file. If I exit from here, currently I am Vagrant user. Vagrant user has its own bashrc file there. So if I want to make this variable permanent for Vagrant user, then I need to edit bashrc file of Vagrant user. But if you want to do it globally for every user, then you can use this file Vprofile. Now this is global. So I go to the end of this file, Vprofile file, and I can place my commands over here. So I'm going to say export season equal to, and this time I'm giving a different value because I also want you to see the preference between these two files. So I will set here, let's say summer. No, wait, let's go for winter for now. Okay, so the sequence will be like this. First Vprofile file will be sourced and then the bashrc file will be sourced. So what I did, I exported same variable in profile and same variable in bashrc, but Both has different values. Now let me log out and log out from Vagrant user also, and log back in now to the Vagrant user, Vagrant SSH script box. Okay, so I'm going to say echo $season, and let's see what's the value for Vagrant user. Winter. So this is coming from etc profile file. Okay, that file. But if I log into root user, echo $season, monsoon. Now for root user, yes, profile file is for everyone, but then bash rc file is overriding that variable for the root user. Alright, so the moral of the story is, if you want to make variable permanent for everyone, then edit etc profile file. If you want to make variable permanent for a user, then update the bash rc file of that user by giving the export command. Okay, so let's wrap this up. So export command is to export the variable, and you can place that command in .profile, .bashrc or etc profile file. etc profile is for everyone, .bashrc and .profile or .bash profile is for the user. And that is all in exporting variable. I will see you in the next one. In this lecture, we will learn about user input. How we can make our script interactive, taking input from the user and then execute the script. So it's done simply by using the command read and the variable name. When you execute such script which has a read statement, it will wait for the user input. User enters a value, will be stored into the variable, and then we can use that variable. So let's take a simple example. Okay, so that's the script. Just some print statement and a read statement. We say enter your skills, and then we say read and a variable named skills. Or I'll just say skill, a single variable. And there also I should be editing it. Now what read does, it waits for the user input. User enters a value, it gets stored into the variable, and then you can use that variable as we are printing it. There's also some options with read -p, which is for prompt. So it's like a typical prompt. It's going to print this and wait. User enters a value, it will store into that variable. -s, another option that will suppress the input. That means when the user types, user will not be able to read or see, which is mostly used for things like password or any secret. So we are telling user, we are giving user prompt for username and a prompt for password. User enters, and then just simply a print statement. So we are printing the USR variable, but don't you dare print pass variable, because if you print that, then what's the point of using -s? That is so nobody can see what you're typing. Let's make it executable and let's run it. There, so it's waiting for the input. I'm going to say my skill is cloud computing. So it prints that, and then that is the prompt. So let's give a username and password. Now I'm going to type. I'm typing, but it's really not printing anything. That's because we used -s option to suppress the input. So that's how the read works. But it's really not recommended in DevOps, at least, to make the script interactive, because we run our scripts from background, from some other tool, and we really don't want user to interact with the system, because user interaction is always error prone. Well, in any case, you need input from the user, you can use read. That is all in this lecture. I will see you in the next one. Welcome to the decision making part. So far, whatever scripts we have written are really series of commands that executes. Our script cannot make any decision. But what if you want your script to make some decisions? If something fails, you want to do something else. Or if value of the variable is so and so, then do this, otherwise do something else. Making the script smart. And that's how we can do it, through if statement. So we say if, we give some condition there. So condition is basically a test case which will compare something with something. And if that is true, then it executes our commands. If that is false, it does not execute our commands. And we can do a few more things. If this fails, we would like to execute something else, or something else, or something else. So we can have if condition, then else if condition, multiple else if condition. If everything fails, then finally we can fall back to an else. And we'll see how that works. So I'm back in my script box. Let's write 8 if 1.sh. Okay, so what we will do in this script, we'll take a number from a user and we'll compare if it's greater than 100. We print the message that it's greater than 100, but if it's not greater than 100, we'll print another message. So let's take read and take input from the user. Let's take a variable num. Now we will put a condition if square bracket and give a space. Take the variable. So we take the variable that user enters, we compare it with, this is the operator. -gt means greater than 100. So two operand, we are comparing with an operator, and if this is true, we say then, and we'll give some space so it looks better. If this is true, we'll say we have entered in the if block, and we'll give a command sleep. So it sleeps, waits for 3 seconds, and then we print our message. Your number is greater than 100. We'll give another echo, an empty line, and then we'll put some commands, let's say date, and we can close it. So fi is for closing, if is for opening. Now you really don't need to give any space, but it really looks better if you give some space, because in Python script this will be mandatory. Here it's optional. And finally we'll give a message that execution completed. Okay, let's run this. Oh, before that, take a look. Square bracket, a space, variable, space, operator, space, the another operand, space, and the square bracket. So that is the syntax. Then your code, fi, closing. If this is true, it will execute this code. If this is false, it will not execute this. It will just execute the rest of the code. So let's save this. Let's make it executable. Oops. +x. And let's run this. Okay, it's asking a number. Let's enter something greater than 100. Let's say 120. Okay, we have entered the if block because the condition was true, and yes, your number is greater than 100. The date is printed and the rest of the code. Now let's give something less than 100. Let's say 50. And you see, the condition was false, so it did not execute our if block. What if you want to execute something else? Let's copy the script with the name 9. I will say underscore there. Now I can put an else block. So we will basically say else just before fi. And we will print another message here. And this command will only get executed if this condition is false, which simply says your number is less than 100. Let's save this. Let's clear the screen and let's execute that. Okay, enter a number. I'm going to say 60, which is less than 100, so it should execute the else block. If I enter number greater than 100, then the if block. Welcome. In this lecture, we will see one more statement from the conditions which is called as else if or elif. You have seen in the previous lecture with if we give one condition, if that condition is false we go to else. But what if we want to check multiple conditions? If this condition is false, then try other condition. If that is also false, then go to the else. So let's take an example. I'm going to run the command IP address show, which will show all the network interface. Now let's say from my script, I want to count how many active network interface are there. So here we see 3, but basically we have 2. The first one is loopback. So we want to ignore that, and we'll see how we'll do that. But one thing that is common across these 3 interface, let's find something, let's say MTU. Yeah, that text is common. What if we can count the occurrence of MTU, ignoring this one? So first we have to ignore this line. So we'll say pipe grep -v, and let's take some text from this line, which is loopback, that is unique. So that line is ignored. And now we'll count the occurrence of MTU, and I want to ignore the case, and I'm just interested in the counting, so I'm going to say C, which will basically give me the number of that occurrence. So it says 2. Okay, let's clear the screen and let's run this command once again. So number of time the MTU is occurred is 2 times, so we can say we have 2 network adapter, but I want to do it through the script. So first I want to store this into a variable. And again, I want to put it in the script, so let's write a script. We'll say 9 underscore if elif dot sh. So the occurrence will be stored into the variable value, and now I'm going to check if $value is equal to EQ, equal to 1. That means I have 1 network adapter active. So I want to print that message, but I also want to check if it's greater than 1. So I'm going to use a statement called as elif and put one more condition there. $value -gt greater than 1. And I'll say then I will say found multiple active interface. Else, and there could be a chance where there is no active adapter, excluding the loopback. We're already excluding the loopback. So we want to print a message, no active interface found, and then close it, fi. Fi comes at the end, the closing. So we are checking multiple condition. If this is true, this gets printed, that's it, end of the story. But if this is false, it checks this. If this is true, it executes that. If that is also false, then it finally executes the else. So one of the statement will get printed, and we know which one it is going to be. It is going to be this one. We already checked. There are 2 network active adapters. So let's execute this. So let's run this. And there you go. Okay, we have 2 similar names. Let's rename these things. So this I want to rename with the name 10, because that's the 10th script. Okay, let's run it once again. So by using this knowledge, now we will write a script in the next lecture to monitor, process, and take action based on that intel. So wrap this up. I will see you in the next lecture. Welcome back. I know in previous scripts you must be thinking -gt, -eq, what is that? Yes, you understood that those are operators which are comparing, but where did that come from? Well, Bash has many operators that you can use. Some of them are displayed on the screen right now from the Decoding DevOps book. Like exclamation is a negation. If anything is true, it will make it false. If anything is false, it will make it true. -n. If a string length is greater than 0, it will be true. And -z is the opposite of that. Or to compare, instead of EQ, you can use single equal to. Not equal to, you can use exclamation and the equal to symbol, and EQ, GT we have seen, LT is for less than, and then we have single operators. What I mean by that is they just need single operand. So -d, and you give a path and it will say true if the directory exists, -e if the file exists, -r if the file exists and it has read permission, and there are a few others. Now we'll use some of them in the upcoming script, but I want to show you the use case of the question mark variable, which is used a lot. So we have seen that if a command is failing, the exit code $question mark value should be non-zero, but if the command works, its exit code should be 0. 0 means true in bash scripting and non-zero means false. Or we can just use the numbers. So let's take an example. I'm running the command systemctl status httpd. The process is running. Whenever there is a process running, there will be a PID file that will get created. So if httpd is running, there should be a PID file for it, var run httpd.pid. This file will contain the process ID, but if the process is dead, let's stop this process, then that file will cease to exist. You see, no such file or directory. Now if we get no such file or directory, then the $question mark value will be non-zero. Now that is something we can use. So let's start the httpd process first. The PID file appears. Now we will write a script that will detect if a process is running. If it's not running, it will start the process. We'll name the script as 11_monit.sh. And by the way, there is a tool called as monit that does exactly the same thing. And you are really writing a script that monitors process and can take action as well. Okay, so script runs that command and the exit code should be 1. So $question mark equal to, sorry, it should be EQ 0 if the file exists, and we just say if the file exists, that means the process is running. Else we will say the process is not running and we'll also start the process. Yeah, that's what we can do. Now we can really conclude the script. But what if there is a problem and this process does not start? The user should be informed that it tried to start the process but it did not start. That means we are going to use one more condition there now. We are going to give a nested condition. Okay, there. So I'm starting the process, and if this works, the exit code should be 0, and if it's 0, that means the process started successfully, else the process failed to start and now you should contact the admin. So there is a nested condition there. Just make sure you're closing the conditions properly. So this is a nested condition inside the else block. And I will also put few other commands like date, and I will make it a little more readable for the user. Okay, so some hashes there, and we are redirecting the output to dev null because we're really not interested in seeing its output. We're just interested in the exit code. Now I said I'm making it readable for the user. If you wanted to make it readable for yourself, please use comments. The reason I gave those hashes and date is because I'm going to make it as a regular process which checks our httpd process, and it will also redirect. We are also going to redirect all the output to a file like a log file, and we'll see that in a moment how we'll do that. But let's first save this file and let's test it. Okay, so it says httpd process is running. Let's try and stop the process. And now let's execute the script once again. There, it found out httpd process is not running. It is starting the process, and the process started successfully. Now, this really is a nice script, but it's going to become more awesome if it runs automatically by itself, let's say every minute. So if our process goes down for some reason, it is going to check that and start it, and it's going to check that every minute like a monitoring tool. And for that, we need to schedule the script, and we are going to do it through cron jobs. So run cron tab -e. Oh, before that, let's get the path of our script. Opt scripts 11 monit.sh. Okay, let's copy the path and let's run cron tab -e. Cron jobs are scheduled tasks. So cron tab -e is going to edit. Let's open this. It's going to open a VIM editor. You go into insert mode, and then you can give the command that you want to run basically, and when you want to run it, that schedule you need to pass. So we have 5 values over here. I'll put 2 hashes or a single hash, which will be ignored. So the first value is going to be the minute. The second is going to be the hour of the minute. So I'll just say HH. Then date of the month, like 1st, 2nd till 31st. And then the month itself, I'll give small m here. 1 being January and 12 being December, like that. And then a day of the week. 0 being Sunday, 1 being Monday, like that. So for example, if you want to run something every night at 8:30 p.m. So I'm going to say 30, the minute, and 8 p.m. I said, so 20. Day of the month, or a date of the month, 1, 2, 3. So I'm going to say here star. That means run it on every date. And which month? I'm going to say run it every month. So just star there. Day of the week, I want to run it, let's say from Monday to Friday. So 1-5, that's a range. Okay, so that's one example, right? And then you can give the command that you want to run. Right, both are commented, so it's not going to really work. Now I want to run my script every minute, so I'm going to say star, and for hour also every hour, and then every date, every month, and every day of the week, Sunday to Saturday. And this is going to run, but it's going to generate the output that I want to store all that output to a file. I'm going to save it into var log. I'm going to say monit_httpd.log. So all the output goes into this file because we need the output to track what's going on with our HTTPD process. Okay, now let's save this. All right, so we have installed new cron job. Now let's stop our HTTPD process. It's going to run every minute, so we have to just wait and watch. So it's been more than a minute when I stopped the HTTPD process. Now the log file should have been created by now. There, the file is created. Let's look at the content of the file. Var log monit. There you see. So it's like more than 2 minutes now. So first the process I stopped. So it says now I try to start and it is running at this particular date and time. And then again it ran after 1 more minute and then it was already running. Right? Let's stop it once again and you can try that. Stop it, start it. Right? And you can tail the logs. Okay, there you see. And really, congratulations, you have created a monitoring plugin. Now, yeah, there is an actual tool that can do that and much more sophisticated way. But the point of this whole exercise was to train you on scripting, an intelligent script. Okay, now same script, but with a little different logic. So we are basically checking here the exit code, but we can do one more thing. Or really the other way. I can just give here the operator -f and give the file. So -f operator gives single operand. It just checks whether this file exists or not. If this file exists, that means your process is running, else it is not running and it tries to start the process. So it's really just the matter of creativity. But at the end of the day, the result matters. Both script does the same work. And trust me, there are many more methods to do the same thing. And this will all come with experience, and you can make your choices which method to use, or you may have your own style. I'm a big fan of exit codes, especially in bash scripting, so I usually use that. Alright, so we did good work here. Let's see in the next lecture how we are going to do repetitive tasks through loops. So I'll see you in the next one. Loops. Running something again and again and again. There are two kinds of loops in bash scripting, for loop and while loop. There are few others, but we're going to deal with that. So for loop runs for a definitive number of times. It's basically going to run on a sequence, a list of something. Let's say you want to add 10 users and the command is user add. The only thing that changes is the username. So you can either run user add command 10 times, or you can write a for loop that runs user add command 10 times for you, and every time something changes. Username basically. Or maybe you have list of servers where you want to log in and execute the command. So you can run it on a for loop to log into these many servers and execute your task. This really saves a lot of time. Let's see how it works. Okay, let's write a script. 13_for.sh. Okay, so this is how it works. This is the syntax for, and you give a variable name. Let's say I'm going to give var1 in, and then you give the list of the item or sequence. So I'm going to say Java, just something, okay? Java, .NET, Python, Ruby, PHP, and then I'm going to say do what? Okay, run these few commands. Just printing looping, and I'm going to say value of var1 is $var1. Oh, we also have to close it. Let me close it. So we have to say done for the closing. So like in if, you have if and fi is for closing. Here for begins and done is the closing. And in the middle, whatever commands we give, it's going to run again and again until the sequence is exhausted. So first, the value Java will be stored into the variable var1. It will execute the code, and it's a loop. It's going to come back. It's going to store the next value into the variable, execute it, then next, till it exhausts the sequence. And I would like to put a sleep there. So it's because it's going to run really super fast. So I'm just going to just sleep 1. So it runs a little slow. So let's save this. And let's make it executable. And let's run it. Okay, it's looping. Yeah. Nice. All right, let's go back. So these set of commands are going to run these many times. 1, 2, 3, 4, 5. 5 times. All right, and you know what? I can put one more echo here, so you can see like it is separated. Okay, let's see one more example. Okay, 14.for.sh. Okay, so let's say I have a list of users, or I'll just give the proper name, my users, and I will give here the username. I'll say alpha, beta, gamma, and that's all. Let's write the loop. For, I will say usr in $my users. Do user add $usr, and then I will also run the command id $usr, and then I'll simply say done. Or I will also print some messages here. Say echo adding user $usr, and also as usual, let's give some separator, echo some hashes. Okay, so this loop is going to basically run 3 times because we have 3 items in this list. Let's test it. All right, now we will see while loop. Now, as for loop runs for a sequence, a while loop runs for a condition. As long as the condition is true, it will keep running the code, which is mentioned in the while block. So let's take a variable counter, and we'll take the value there as 0. And this is the sequence while, and I have to give a condition, like we give condition in the if. Here also we give the condition. I'm going to say $counter, the value of counter, if it's less than or equal to, or just say less than 5. And we'll say do. Okay, so we are printing this to message looping, and we are saying value of C is $C. Not C, sorry, counter. Value of counter is $counter. So the value of counter is 0 first. It's going to check if 0 it's less than 5. That is true. It is less than 5. So it will execute the code. And then it will again come back and again check it. Value of counter is less than 5. Yes, 0, because it's being 0. Every time the loop runs, it will be 0. Each and every iteration. Because we are not changing the value of counter. So this is going to run for infinity. You have to press Ctrl C, then only it will close. Let's see this. Let's save and quit this. Let's make it executable. Let's run it. So this is going to go on and on and on and on and on. Okay, till infinity, because the condition is true every time it's running. So you can use Ctrl C to kill this. Come on. Yeah, all right. Yeah, sometimes you have to press multiple times the Ctrl C. Okay, let's open it again. So we have to change the value of counter. And this is how we can do that. We're going to say counter is equal to $ parenthesis and a math expression again in parenthesis. We're going to say $counter plus 1. Now every time the loop runs, the counter value will be incremented by 1. So in 5 iteration, this condition will become false and the loop will terminate and we will be out of the loop. So let's print echo out of the loop. Okay, and let's also give a sleep because it runs super fast. So let's say sleep 1 second. Okay, now let's run it. Let's clear the screen and let's run it once again. Okay, 0, yes, incrementing 1, 2, 3, 4, and that's it. So when the value of counter becomes 5, it compares 5 less than 5, which is false, and it just throws it out of the loop. Or maybe you want to run it for infinity. Okay, let's try that. Let's copy this script with the name 16while.sh. Let's open that, and I'm going to increment, but I'm not going to check the condition. I'll simply say here true. True. Yeah, that's the true. So that's a Boolean expression. True means true. It's going to be true forever, right? And let's save. And you know what? Let's do something more interesting. Instead of adding, I'm going to multiply. Okay, multiply. So star for multiplication, I'll multiply it by 2, and I need to change the value from, let's start with 2. Okay, so 2 multiplied by 2, 4, then 8, then 16, go on and on. Okay, let's start this. And this is never going to terminate because it's the true loop. Okay, it's infinite loop, but every time it's incrementing the value. Okay, which will be something nice to see. Let's try that. 2, 4, 8, and it's going to go on and on and on, right? If I remove the sleep, it's going to run super fast. And it's going on and on. So make sure whenever you're using while loop, you know how to terminate it. Okay, that condition needs to become false at some point of time. Otherwise, it will run for infinity. And imagine that running in the background as a cron job. Okay, that will put some load on your system if you're doing some heavy operation. All right, that is it in this while lecture. I will see you in the next one. Welcome. In this lecture, we will talk about a remote execution. How we can execute command from script box to web01 and web02, and we will also add one more machine, web03, which will be Ubuntu machine. So let's check at our Vagrant file. So from script box, we will execute command that will run on web01 and web02, and I will also add one more machine which will be web03, and that will be with Ubuntu operating system. Now this is not mandatory. If you want to skip, if you do not have enough resource on your computer, on your laptop, then you can skip this one. But I'm going to do this web03 because this is going to be Ubuntu operating system, and we will be using some techniques in our script that we have learned previously to execute script for a different operating system. I'll say Ubuntu Bionic 64. Also IP address I have to change, and let's note down the IP address 10.13, 14 and 15. Okay, now let's bring up all the machine. We can just say Vagrant up. Okay, VMs are up. First we will set host name for every machine. So Vagrant SSH web01. So open the etc host name file and let's give web01. Let's log out from web01. Let's log into web02. Let's get into web03 now. And this is Ubuntu. I said it is optional. If you want to skip it, you can skip it. Okay, let's log out. Okay, let's get the IP address of the machines. We are going to add name to IP mapping in the script box. So script box can refer to all the machines with their names and not IP addresses. But first we have to save those IP address in the etc host file. So let's log into script box. Okay, we will open the file etc host. Okay, done with that. Now let's try to ping web01 from script box. It should resolve to IP address, same web02 and also web03. So let's try to make a test now. We will say SSH Vagrant, which is the user in that machine, web01. Okay, it's asking me a question. Should I log in? Yes, please. And it's asking the password. So Vagrant user password is Vagrant. Okay, same password, same username, and we are in. Okay, and you see the host name, right? We can see where we are logged in. So that was the benefit of setting the host name. Right, so when we log in to that machine, we can see we are connected to that machine. Let's log out from here. So we will not use the Vagrant user. We will create another user called as DevOps in all the web servers. So we'll log into all the machines one by one. First web01. You can do Vagrant SSH from the host machine, or from here itself you can log in. I'm going to add the user called as DevOps, and we'll set the password for this user. So we'll use this user to execute some remote commands, and that will be system commands also, like installing packages, adding users. So we need to add this DevOps user into sudoers file. So I will edit the sudoers file. I will add the user DevOps in the sudoers file, and I'm going to say no pass wd. Oops, I made a syntax error. No pass WD. Okay, then I log out from web01. Clear the screen. Now I'm going to log into web02 and then do the same thing here. After adding the user, again update it into the sudoers file. Then log out from here, web02. Let's log into web03 now and again perform the same thing. Okay, but we can't do this. There's a problem. We can't log into web03, which is Ubuntu operating system, with Vagrant user. Basically, we cannot log in with the password. We can log in only with the key. Now what that means is whenever I was trying to log into web01 and web02, it was asking me password. Right there you see it's asking me password, but for web03 it says permission denied public key. It's not even asking the password for Vagrant user. So web03, which is Ubuntu, does not allow password login, so we have to log out from the script box and we can log in from here, Vagrant SSH web03 from our host machine. This is key based login. Okay, I'm in web03 and I will show you what is the problem. Just run sudo -i in web03 and open this file etc ssh sshd_config file. To any Linux machine, if you're trying to log in with password and if it throws you that error, public key access denied, then huge chances the password login is disabled. So open this file and find the line password authentication. Okay, there line number 56, you can see password authentication, it says no. So my guess was right. We can just say now password authentication yes, save and quit, and then restart the SSH service. It's Ubuntu machine, SSH service name is just SSH. And now let's go back to script box. Now from script box, let's try once again Vagrant at web03. And you see it's asking the password and we can log in. Alright, so we're able to log in with password. Now let's continue with our activity. We are going to add the user DevOps, and this is an Ubuntu machine, so I'm going to use the command add user DevOps. It should also ask me the password. And we have to add the users in the sudoers file. So I'm going to say export editor equal to vim and then vi sudo. Okay, so DevOps user in the sudoers file with no passwd. Alright guys, so now we are all set to do the remote execution. Now let's come back to our script box. Let's come home. So whatever we did so far in this lecture was the preparation so we can execute command over SSH or remote execution. So this is how it works. So when you do SSH, and we will be using the user DevOps as I said, and let's say web01. When you do SSH, it gives us the shell, but if with that we give a command, let's say uptime. Now observe what happens. Look at the prompt. Okay, it is asking the password. Let's enter the password. So we logged into web01 with the password. It executed our uptime command and then we are still in the script box. So we really don't need to log in, execute command and log out. We can execute the command from here itself. So we can do that, but the problem is every time we do it is asking us the password. Because of course we need to provide the authentication, but there is also one more way to log in password, which is key based. We're doing password based login, but the key based are considered as the safer login. And for that, all you have to do is you have to run this command ssh keygen, which will generate the keys. So it's key pair. You read there, it's generating public and private key pair. And this is where it stores the key in the user's home directory .ssh, and that's the key name. This is the private key name. Hit enter and hit enter here. Again enter. So this is the private key and this is the public key. It works like lock and key. So this is going to be the lock, the public key, and private key is going to be the key to open to that lock. So we're going to put this lock on web 01, web 02, web 03, and we will have this key to open that lock. And which is not so difficult to do. All we have to do is we have to run ssh-copy id command, give the username on which you want to put your lock, @ and the host name. So it will take this lock and apply it for this user on web 01. Let's hit enter. It will ask password. Enter the password for DevOps user. And that's it. Lock has been applied. Let's do the same for web 02. And let's do again for web 03. Okay, now let's test it again. Let's clear the screen. And now let's say. So again, remote execution, but this time it is going to take the key to log in. So you see it did not ask the password. Now, the way it works is in your home directory, you have the .ssh directory. In this .ssh, you will have the private key. If your key name is this id_rsa, this becomes your default login key. So whenever you are doing an SSH, it is using by default this key to log in. So what really is happening is it is actually doing ssh-i .ssh id_rsa. So it's using this key to log into this machine and execute our command. See that? Now, the content of the private key and public key you should be able to read and understand. I mean, not really understand, but you should be able to understand that it's a private key or a public key. So let's check this key id_rsa. So you see it says private key. Now the key name can be really anything. Okay, but when you do a cat, you can see the content. If it says private key, it's a private key and private key will be longer. Okay. If you see the public key, rsa.pub, the public key will be a little shorter. Okay, so when this lock matches this key, right, so they are generated in pairs together. So when this both matches, you get authenticated. So that's the analogy. So that's all in this video. I will see you in the next one. Alright, welcome to the grand finale of this bash scripting. Whatever we have learned so far, we are going to put all that into use and create really some awesome scripts, or should I say frameworks. Now, whatever we will do in this grand finale is the base of many other automation tool out there. If you are able to do what we are doing in this lecture, then you can learn and master any automation tool after this. So we are going to do a web setup in this script, but so far we have been running the scripts on the script box itself. Now we're going to run our scripts on web 01, web 02 and web 03. So I'm going to create a separate directory inside this. I will say remote_web setup. And let's get into this directory. First, I will prepare a host file. Okay, you should have a host file like an inventory file. I will say host, or I'll give it name as remote host, something like that. And if you're using IP address, give the list of IP addresses here, or if you're using host names, which you have already configured in the host file, so you can give the host name web 01, web 02, web 03, like that. So how many ever you have, 10, 12, 20, 50, hundreds, you can all mention that into this file. Okay. So these are going to be our targets. Now let's test the login to all this machine. And I'm not going to log into them one by one. I'm going to use a for loop. I'm going to use variable host for host in and backticks cat remote host. This semicolon is a terminator in bash. That means this line terminates over here. So, you can start typing things in the same line. So after this we have do, right? And we can say do $, do echo $host and done. So what really is going to happen? One by one, every line will keep getting stored into this variable and we are just printing it in a loop. Okay, now instead of printing, I am going to do an SSH to it. So SSH, I'll give the username, which was DevOps we set. and with that we'll give a command. Let's say I'm going to give free -m, or you know what, better I'll just give host name. We are just testing the login. Now if you're wondering the same output, that's because the host name command is going to return the host name. But if you want to execute some other command, you can do that. Now see, it looks so simple, but it is so powerful. Imagine you have hundreds of hosts in that file and you can execute commands on them by just one single line of code. Okay, maybe you want to install some software over there, right? So I can say sudo yum install git. Okay, so that worked, but except for web03. You see there yum command not found? That's coming from web03 because web03 is Ubuntu operating system, and in Ubuntu we do not have yum command, we have apt command. And we'll see how to fix that. That's what we are here for actually. So test is working fine for remote execution running in a loop. Now our job is to write a script which will do web setup as we have been doing on script box. So we'll copy some existing script and we can modify that. So we'll take this one, 3 vars web setup. So // copy that here and let's rename it to, we are going to say multi-OS. Yes, multi-OS, because we have Ubuntu and CentOS mixed. This script was written only for CentOS, but we will modify it and make it multi-OS so it works on multiple operating system. And for that we need to check some conditions. We are going to run a command yum -help and redirect all its output to dev null because we really don't want to see that output. We are just interested in the exit code. Yes, if the exit code is equal to 0, that means it is a CentOS operating system. Now we can print that message, echo. I'll give here 3 space, that's better. Running setup on CentOS. Okay, then I'm going to just make sure everything comes like this. Okay, also we have to make sure we set these variables also over here. We are going to not set the variable up there, but when the condition is decided, when it is a CentOS, then we are going to say the package is HTTPD and service is HTTPD, because for Ubuntu it will be Apache 2. So I'm saying here okay, it's proper line spacing I will give so it looks good. So I've given all the spaces, and that's the if block. If it's CentOS, execute this, and I'm going to say then else, because the other operating system is Ubuntu and we can just then give all the Ubuntu commands. So I'm going to save this file and do a cat to it so I can copy all this content and just make the changes then. So let's just copy this. These are all the CentOS commands for the deployment, and we are going to paste everything here, and I'm going to say fi, and we'll make changes as per the Ubuntu operating system, starting with the comment set variables for Ubuntu. And so the package is Apache 2 and the service name is Apache 2, and we need to give here apt instead of yum. And before this we need to give in Ubuntu we have to give sudo apt update. Yeah, and that's it. systemctl start $svc, that's a variable, so we don't need to change anything, and that all these are variables, right? You see that? Now I hope now you understood now the power of variables, right? You can use the existing code, change the variable value, and that's it. All right, so that is a reusable code or multi-OS. All right, let's see once again. So if this returns the exit code 0, then CentOS deployment, else the Ubuntu deployment. Okay, let's test this script locally. Yeah, see, setup running on CentOS. Because script box is CentOS, so that worked. Now, in the next video, we will see how to push the script to all the web server and then execute. That will be the proper remote execution with scripts. So wrap this up and join me in the next lecture. All right, so welcome to the last session of Bash scripting. In last video, we have seen how we can have a script detect operating system and based on that execute the right command. In this session, we will push this script to all the remote machines, web 01, web 02, web 03, and then execute it. And for this, we need to write another script. Now, if you don't know how to push files to Linux machines, well, it's pretty simple. You just need to use SCP. Now, SCP uses SSH. So if your SSH is working, your SCP works. So let's create a file, echo, I'll say test file. Let's just test file.txt. Okay, so let's say this is the file and I want to push it to the other machine. So I'm going to say test file source and then give the destination as you give for SSH. Username @ and the host name or the IP colon, and you have to give the path, for example temp. Okay, so that's how you can push the script, right? Let's try a different directory, root directory, and says permission denied, because root directory is owned by root user and DevOps usage is trying to access root directory, so that's why permission denied. Similar way, you can fetch the file also. Instead of source, you just change from source to destination and destination to source. And it did not ask us any password, anything, because it is using the key. Okay, as I said, SCP uses SSH protocols. It's basically using our key .ssh id _ RSS. Okay, so it's happening like this. Yeah, say /home/devops. If there is no key exchanged, then it will the SCP should ask you the password. So now we'll write a script that is going to push our multi-OS web setup script and then execute it. So let's write it. Let me clear the screen first. I want to copy this name and I'm going to write the script name as web deploy.sh. All right, so I'm going to write the for loop for host in cat rem host file do echo connecting to $host. Little cosmetic. Okay, so now let's do the SSH here. SSH. Let's also set the host name as the variable. Username as the variable. So I'm going to say USR DevOps. So $USR $host. Right, so that will have the host name. Now, my bad. We have to do first SCP copy push our script. That script to this location colon, we'll say temp. Okay, and then simply execute the script. How? Well, SSH and execute. /temp/ give the path of the script And that's it, done. Or we can do some cosmetics, we can print some messages. Alright, so just put everything in between these hashes and printing messages, like connecting to host 1, pushing the script, executing the script. And but this basically contains just two things. It's going to push the script and execute the script. Now, if our script doesn't have sudo, then you should give sudo here, because a script contains command of installing software, managing service that needs root privileges. So either you do sudo and execute the script, or your script should have the sudo commands. And once this is done, I also would like to delete the script. Now script generates data, and that data we are cleaning in the script itself. We have the commands for that, but the script also needs to be cleaned. So once the execution is completed, I want to basically clean execution. Okay, remove the data which got created while the execution. So let's save and quit this. Let's make it executable, and it's showtime. Alright, so that worked for Web 01. Okay, and then this is going for Web 02. Okay, Web 03. Great, it detected that. You see that it's using apt there. Nice. Okay, that completed. Let's check that. So the IP address etc host, right? Because my laptop does not know it's Web 0 and Web 02, right? We don't have entry in the host file there. So we'll access all the IP addresses from browser. So that's Web 01. Awesome, it's set up. And that's 14, Web 02. Nice, that is also done. And that is Web 03, which was different operating system. Alrighty, right. So you see the amount of power now you have in your fingertips, or at your fingertips. Imagine this REM host file, remote host file. Imagine there are hundreds of machines over there. Right, so you can write a simple script and push it and execute it and manage hundreds of machines. That's how we used to do automation for many machines like a decade back. But now we have much more fancier tools like Ansible, which makes our life easier. But if you really want to learn and master those tools, you should have these background of scripting. You should understand how this condition works, how this for loop works, how you can use it to achieve some complex tasks. And trust me, if you can do this, if you have come so far, you have done a good job, a great job. And now you are eligible to learn any automation tool. And not only just eligible to learn, even eligible to master them. So overall, really very good job. Now we can conclude our bash scripting section. I recommend you go through all the scripts, download from resource section, go through all the scripts. And once you do this, wrap this up and join me in the next section.